And it's me, Rory Preddy. Welcome to the Asian Pacific leg of this incredible conference, Microsoft JDConf 2024. I'll be your host in this exciting lineup of incredible speakers, and we have a riveting lineup. I know it's riveting because I'm speaking a little bit later in the day, and I feel very competitive to get my game on when I see the roster of speakers that we have here. So I've got a little bit to introduce you to the session today. We have a code of conduct, which basically says, be a good person. You can go to aka.ms/reactor C, I think that's an O, or it's either a 0 or an O. So you can make it up. Try it out though. And just be a good person, play nice. And if you're in the YouTube comments there, give us a thumbs up, give us a heart, and yeah, give us some love. And yeah, there are 5,000 Microsoft reward points, which you can get. Now, I even checked on, I went on, I actually have 5,000 points because I use Bing as my search engine and to create images. And I've already got that. And you can get a lot of nice things on there. The Microsoft Rewards program, you can get Roblox vouchers, gaming vouchers. You can even get and contribute to a charity of your choice. So definitely go in there and go into jdconf.com and check out how to get those points. And all you have to do is just show up, be a good person, and well, you don't even have to participate. You can kind of just fall asleep. You still get those 5,000 points. Now, throughout the session, we want to hear from you though. So definitely take your phone out, go to aka.ms/jdconf/survey and tell us what your experience is though. Tell them that you like my blue shirt and my blue background, or just tell us a little bit about yourself and on what you want to hear going forward in current sessions and in this session. And then finally, if you want to get some learning, your groove on though, go to the JDConf College. Some of the sessions there are actually proctored myself and I created myself though. It's a great way. And once you do that with the learning challenge, you get the badges associated with the achievements. And then you can actually go onto your LinkedIn, a small little company that we own also, and you can showcase those badges when you detail this though. So it's more important also to build your career, to build your relevance and your education with the Cloud Skills Challenge. So we've got a hectic roster here. We've got my good friend starting very soon, Josh Long, who's going to talk about Bootiful Spring Boot 3. We've got virtual threads. We've got generative AI with Cosmos DB, container apps, another Java service enhancement using generative AI, Hotspot Scalar replacement, and optimized Java apps for high traffic scenarios though. So great roster, absolutely incredible. And then throughout the session, we'll also promote my talk, which is a little bit later, Semantic Kernel for Java. Blatant plug there, but we'll go through some of those talks. So that's everything that we want to address today though. And at any given time, reach out to the moderators if you need anything, if you need accommodations or anything like that. And I'll be looking forward to answering your questions. I've already connected over there live on YouTube, and I've got your comments here. We see some people from India. We see some people from Hong Kong. And I'm based in South Africa, and that is on the bottom bum of Africa, and I look forward to seeing and hearing from people around the world. That's everything I wanted to cover. So I do want to bring in Josh if he's available, and else I can just hum a good song and drink my Red Bull. It is 3 a.m., 4 a.m. in the morning today. And I know that Josh, you're at the same time zone right now. You're in Romania or Bulgaria or something with an area in it.
I'm in Bucharest, Romania. You got it.
And we're buddies because we're both sleep deprived buddies. So
yeah, 3:30 in the morning.
Everyone, be gentle on us right now. We're vulnerable.
Nothing a good cup of Java wouldn't fix. Let's get started, shall we?
Yes, go.
All right. Hi, everybody. Good morning, good afternoon, good evening. How are you doing? I'm glad you're all here. Thanks for hanging out. My name is Josh Long. I work on the Spring team. I'm at Broadcom now. You might have known me from Pivotal or VMware or whatever. It seems to change day by day, but the Spring team are now at Broadcom, and there I am, as I've always been, a Spring developer advocate, and I am, of course, a dutiful Kotlin Google developer expert and a Java champion, and I'm a YouTuber. It's cringe, I know, but hey, what are you gonna do? YouTube.com @coffee software, and I'm on the internet. I'm very online. I've got an email address, so you can find me there if you have questions, comments, feedback. Friends, there's never been a better time to be a Java and Spring developer, and I've been persuaded of that for a lot, but especially of late. My goodness, there's just so much good stuff. So to see that in action, to make that point, let's go here to my second favorite place on the internet, start.spring.io, and we're going to build a brand new application, starting as always with some questions. The first of which is, what do we want to name our service? I am going to name it Service, and the reason I'm going to name it Service is because I am great with names. I get that from my father. He was great with names. When I was a small boy, we had a small white dog, and my father named him White Dog. Great with names. That said, my mom, she always tells me, you're very lucky that I named you. And yeah, that's probably true. So I'm going to call it Service. Then we have a choice about what version of Java to use. Friends, any version of Java here is fine as long as it's Java 21 or later. So I guess that means that only 2 versions of Java are fine here. You'll notice that we don't have Java 8. Friends, Java's 17, 21, and 22 are technically superior to Java 8 in every conceivable way. They're faster, more robust, more secure, more performant, more operations ready, and they're morally superior. You won't like the look of sadness and shame in your children's eyes when they see that you're using Java 8 in production. Don't do this. Be the change you want to see in the world. Do the right thing. Use at least Java 21. And we'll talk about why in due course. Friends, I think I'm happy with those selections. Let's add some dependencies. GraalVM native image support, some web support, some Postgres support, some Spring Data JDBC support, the Docker Compose support. And I think we've only got 25 minutes. I think that will have to do. You know what? No, one more thing. Let's go ahead and add some AI. It wouldn't be 2024 if we didn't do that, right? So I'll bring in some Spring AI support as well. Hit generate, and we're going to open this up in our IDE. And again, it doesn't really matter what IDE you use, so long as it supports the version of Java that you're using, which of course all of them will, and your build tool, which of course all of them will. So I'm going to go ahead and let that load. And friends, we've got a brand new application. It's a data-centric application, and I want this application to talk to our SQL data source, and I also need a data source. So to that end, on the build in start.spring.io, I asked it to build a Docker Compose file. I selected the Docker Compose support. It gave me a Docker Compose file for Postgres. I'm going to go ahead and tell Spring Boot to not bother restarting that Docker Compose instance on every restart. So I'll just comment this bit out, and then behind the scenes, I'm going to say Docker Compose up, okay? And that should start up the Docker Compose file that we've got running in the background there. That'll save us just a wee bit of time because we have very, very little of it. Okay, so there we go. There's the actual thing. I'll now specify how to connect to that here in my application properties. So Spring data source password equals secret. And then, of course, the username is my user. And then, of course, the password is, the URL is JDBC PostgreSQL localhost, and it's my database, isn't it? I think that's right. That looks, that looks great. Good. So now I've got that, and if you want, you can have your IDE connect you to that if you like. I'm not going to bother, but it is a data-centric application. We also wanted to initialize our SQL database for us. So we're going to provide some schema, and we want it to automatically run that schema when we start our application. So I'll go ahead and do that here, data.sql, and I'll just say delete from customer. Okay, and then I'll insert some records into it just so that we have something quick with which to work. So my name is Josh. It's nice to meet you. I'm joined, of course, by my pal from years and years and years. Rory, we're going to have a schema file in here as well. So schema.sql, create table, if not exists, customer ID serial primary key, name, text, not null. There we go. There's my basic schema. Fantastic. Now we've got our basic application. We need some, we need some Java code to actually talk to it and to make it easy to work with. So let's go ahead and describe that here. I'm going to create a record. These are one of the amazing features that I love that taken together in Java 21 culminate in a feature that the Oracle Java team are calling data-oriented programming. And that includes records, sealed types, smart switch expressions, and pattern matching. We don't have time, not nearly enough time to go into all that, but suffice it to say, they're really good. And this is just one small part of that. So don't sleep on this, but also check those other things out because taken together, they give you a lot, right? I love records. I love them so much. They are just so nice and intuitive. We're going to create a repository that allows us to sort of make short work of the business of repository of talking to our SQL database. Okay, so customer integer. There we go. Now, we want what happens if I start this application up? Well, I guess it'll run the SQL, and that'll be fine. But we don't have any way to sort of to inspect it to see what's happened. So I'm going to create a REST endpoint. Okay, so I'll say response body class customer controller, and I'm going to inject the repository that we just created into the constructor like so, and I'll create an endpoint here called customers, wherein I'll return, guess what, a collection of customers. Did you see that coming? Did you see that coming? I did not. So there we go. There's our very simple application. I can just run this application, right? Just run it in the IDE like that. We'll let it spin up. There we go. Up and running. It's failed. I wonder why. Oh, it's failed because it's not able to connect. Let's see. Localhost, my database, PostgreSQL, my user. I feel like I did my part. Database, my user secret. Do I have a conflict of some sort in the database connectivity? Database system is down. Why? Let's see here. Let's just go ahead and purge whatever database was running. Sometimes you get conflicting containers. No, that's actually fine. So database, Docker Compose up. Let's go. Okay, it's up and running. Database was shut down. Okay, why? It's ready to accept connections. That feels like that should work. So we've got password secret my user. All right, it's called my user. Password is it's called my database. Do I have that all right? So Postgres, JDBC, PostgreSQL, localhost, my database. And what's the issue then? What do we have going on here? Oh, you know what it is, friends? The Docker file doesn't automatically expose the port on the host, so you have to export it. So I'll go back here to my local machine, Control C, and this third time surely is the charm. We're gonna go ahead and Control C that, restart. Here we go. Okay, come on. See, this is why I'm glad I didn't have Spring Boot restart Postgres each time, because as fast and elegant and amazing as Postgres is, it's not serverless. It's not meant to be restarted all the time. It's just nice to let it run there. Okay, now we're cooking. So we go to the browser, localhost 8080/customers. It worked. Of course, it worked, my friends. It was a demo. It was always going to work. This is a pretty stock standard thing, though. We've got a endpoint we got a web app babysitting a database, right? It's easy peasy stuff. You've seen this before, but this is 2024. It wouldn't be a demo if we didn't have some sort of AI. And to that end, we have the Spring AI project. Now, I'm not going to be able to cover all of Spring AI because remember, it has as its purview the entire RAG pipeline, right? RAG stands for Retrieval Augmented Generation. When you hear about all this hype around AI, remember, you're going to consume AI. You're not interested in developing your own AI, right? In the same way that 99% of us, or 99.99% of us, are not interested in building our own SQL databases either. And in this regard, Java is second to none in its ability to integrate you with the biggest and the best, right? And the Spring AI is at the lead of that pack, right? There are a lot of options here for all the different tools you need. There's work to be done in taking data, making it so that you can query it based on similarity. That's called a vector database, and then get that connected to the LLM of your choice, of which there are dozens, right? And Spring AI supports that whole pipeline. We don't have time enough to look at all that, but let's just talk to a simple LLM. And I've got OpenAI here on the background. Of course, you can use Azure OpenAI if you like. That's a good choice as well. So I'm going to go back to my Java code, and we're going to build a very simple endpoint here, a simple controller. We'll say at controller at response body class AI controller. Okay, and I'm going to inject a pointer to the Spring AI chat client. I'll call it Singularity because, you know, how foreboding could I get? And we're going to create an endpoint here that just returns a story. We're going to tell ourselves a little story. We're going to have the AI tell us a story. So it's story time. Here we are. Get rid of that. Voila. Come on. You can do this. There we go. And we'll say map.of story. And we're going to ask it to tell us a story. But we have to do that by giving it a prompt, right? And so there's actually a whole school of engineering called prompt engineering. That's all about how to write and craft the right prompt. You know, you can get these LLMs to give you like document formats like JSON or XML or whatever. You just have to be very, very specific in your instructions. Okay, we're not interested in that, but let's get going. Let's say, dear Singularity, right? It's very important to be polite, friends. They will remember. Please tell us a story about the amazing Spring and Java developers using Microsoft Azure. Spring Boot and Java developers. Also, please tell the story in the style of famed children's author Dr. Seuss. Dr. Seuss, of course, is one of my favorite doctors, along with Doctors Who, Strange, Subramaniam, Sire, DeVolder, Pollock, and so on. Okay, cordially, Josh. Okay, very good. There's my prompt. And we're going to ask it now. We're going to say var reply equals this dot singularity dot call, passing in the prompt of voila. And we'll say pass the reply. There we go. So I've got the reply. And let's just go ahead and restart that. And let's see what we get. Okay, I'll drink my, oh, it's already done. Okay, so I've got this endpoint. I'm going to go ahead and make a request. Let's do that. But we have to wait. You know, you notice I could have probably taken a drink during that wait, and we got a response. Oh, Spring and Java developers so bright, working with Microsoft Azure. What a sight! They coded and they tested with so much glee, creating apps that would run so smoothly. You get the point, right, friends? We can do the AI. It's here. It's amazing, right? We got this. It works. But what happened when I made that request? We sat there with bated breath, wondering what was going to happen and if this would fall over. And of course, it. Why would it fall over at 3:30 in the morning, friends? Anyway, it worked. But the point is, we had to wait. And what happens from that perspective? Well, I had time enough to take a sip of something, surely. But from the perspective of our computer, what was happening? Well, we have a web framework, and we sent the request into the web framework. A thread was assigned to our request. There's a socket. We got the input stream, and then we got an output stream, and we made a request to a network service. That's the OpenAI REST endpoints. And there's bytes that were being conducted across the wire. And what's happening when we're waiting for that response? Well, we're sitting there on a thread waiting for the bytes to respond, but they never did, right? It took forever. And in that time, what's happening to that thread? Nobody else in the system can use it. This is a big problem. We're bogarting, we're monopolizing that thread. And threads traditionally in Java have been very expensive, right? They're not, they're tied to operating system threads and therefore finite. And this is not a good situation to be in if your one dimension of scale is tied to your ability to increase threads. Not good. Well, Java 21 obviously brings with it a solution. It's called virtual threads. And friends, I cannot stress this enough. This is arguably the single most important thing they've ever added to Java since Java 1.0. I cannot think of a single more valuable and interesting thing. What I want you to do is to use virtual threads, or better yet, not use it. Just let the framework do it for you. And then ask your boss to deposit into your paycheck the money saved on cloud infrastructure spend that you got by moving to virtual threads. What are virtual threads? Well, let's take a simple example that I stole shamelessly and unabashedly from Oracle Java developer advocate Jose Pomar, right? Jose Pomar, comme ça. And I can say merci. So there we go. This is a simple example. And let's say I'm going to create a bunch of threads. Yeah, a new array list of threads. I'm going to create 1,000 threads. Okay, not a big number, but just for simple math here, 1,000 threads. I'm going to say threads or var thread equals thread.ofPlatform. This is the traditional sort of style of creating a thread. It's going to be an unstarted thread. I'll say threads dot add thread. Okay. Now what am I going to do in this thread? Well, I've got a runnable. Let me turn that into a lambda there. What am I going to do? Well, I'm going to sleep that's a blocking thing, right? I'm going to sit there and waste time on the thread. And remember, I have exclusive access to this thread. Right now, this thread is tied to an operating system thread. So I'm going to sleep. And then after that, after I've slept, I'm going to, if I am on the very first of the 1,000 threads, I am going to take note of the current thread name and add it to a set. Now, remember, friends, sets they dedupe, right? If you add the same element twice, it'll only appear once. Okay. So names dot add thread dot current thread dot toString. So I'm taking note of the current thread name, okay? And I'm sleeping for 100 milliseconds, and I'm going to go ahead and now do that again. So that's 2 times 200 milliseconds, 3 times 300 milliseconds, 4 times 400 milliseconds, okay? All the while, I'm taking note of the current thread on which I'm executing. Well, why would that change? Why would that be variable? I mean, historically, it won't, right? So if we then let's go ahead and run through all those threads, 4 of our T threads, t.start, and then we're also going to join them. That is to say, we're going to wait for them to finish, and then we're going to print out the results that are in the names collection there, okay? So I restart the program, and yeah, the physics hold. We started on thread 1, and it has its thread number 74 on operating system thread 15, whatever, and it stayed there. Okay, that's fine, but that means that while we were waiting for that 100 milliseconds, we were just sitting on that thread, and nobody was able to repurpose it. Now, what if we move to virtual threads? Well, that's the opportunity here, friends, of virtual. You see that thing? All I did was I changed that factory method, restarted the program, and there you go. Look at that. The runtime has automatically moved us from this thread to this thread to this thread to that one. All the while, when we did those blocking things, it saw, hey, you're just going to be sitting there. I'm going to move you into RAM. I'll reclaim that thread, and when you're ready to be executing again, I'll put you on some other thread that's free. So even though we didn't change our code at all, save for this one factory method, we got the benefits of something like reactive programming or async await in other languages without the incredible verbosity of async await in other languages. Looking at you, C#, this is an amazing, amazing result, friends. We get free scale here. Huge deal. This is huge, okay? So we've got now virtual threads. Now, obviously, low-level threads, right? This is threading. Most of us aren't going to be working in terms of Java lang thread, even if it's this simple. Most of us deal with things like Spring MVC, which in turn deals with threads, right? So maybe all you need to do instead of doing this is to actually replace the system-wide executor service, right? And so you can do that. There's actually one that's provided out of the box in Java 21. It's called the new virtual thread per task executor, and it's not a thread pool. It doesn't pool the threads at all. It creates brand new ones because now threads are cheap. They've decoupled the one operating system thread from the one Java lang thread. You can create millions of Java lang threads with no problem. There's no metadata heap that is so expensive as before. So this is not really a scary thing now. And that does, by the way, turn a lot of architecture design assumptions that we take for granted up on its head, right? You can say, well, hey, I was going to resize that image. I don't want to do that in the front end web thread pool because I don't want to diminish availability. So I'll send it over a queue to another node. But now, why not? Like, why couldn't I do it? Or sending out an email. Maybe that takes a few seconds. Or doing a report. It's all I/O. It can be done on the front-end web thread pool. You only need one node now. You don't need the message queue and the other node, maybe. I mean, verify for yourselves. But this is a great deal. But still, this is, I can define this. But still, wouldn't it be great if the framework just did it for me? And yeah, it can. So we're going to go here. And we're going to say, Spring, please, wherever appropriate, plug in virtual threads for me. Done. Okay. So now I've got great scale. I've got this incredible virtual thread mechanism giving me the ultimate, scale now. I want to take this thing to production. I've got AI. I've got the freaking Singularity. I've got a REST endpoint. And by the way, this call to the AI, no longer so scary. Our users can now log in and make as many requests as they need. Who cares? Because we're not actually wasting time on a precious and finite thread while that call to the OpenAI REST endpoint is happening. That's a wonderful result. Okay, so now we've got that. What next? Well, obviously I want to get this thing into production. But friends, I want to say, first of all, I want to make this application production worthy. And by that, I mean fast, okay? To that end, there are a few things I want to do. Obviously, I want to containerize it. How do you containerize it? You use build packs, right? Build packs are a great way to containerize an application. Obviously, if you're using Azure Spring Apps on Microsoft Azure, you don't even need to do this. But if you are using something, if you're using raw Kubernetes or something like that, use this. This is an amazing way to containerize your Spring Boot application. It's not just for Spring Boot. You can use it with some of those other hypothetical other languages that I've heard people are using, but I've never actually seen, because why would I? It's a good choice. Remember, friends don't let friends write Docker files. This is the first thing. The second thing is I want to make my application as efficient as possible. And now, don't get me wrong, friends. Java is already very, very efficient. There's a great blog here from 2018, before the COVID pandemic, or BC. And this blog asked the question, which programming languages use the least electricity? And there's a great results here. If you look at this table, I think it's quite telling. C is the most efficient language for machines, not people, okay? It's the most efficient language from the perspective of energy consumed per instruction, right? Rust, zero cost abstraction, is doing quite well. C++, ooh, disgusting. Moving on, Ada, but who cares? And then there's Java. And Java, let's just say, rounding up 1.98. Call that 2, okay? I'm not great with math. Small brain, very smooth. 2.0, okay? Rounding up. So we can say Java is twice as inefficient, or put another way, C is twice as efficient as Java, okay? With me so far? Good. Moving up. We got other languages here. We got Swift. Okay, fine. Got C#. Got Go, away. You've got JavaScript and TypeScript. How are these numbers possible? JavaScript is 4.4. TypeScript is 21.5. I thought one compiled into the other. How is there an almost a 400% disparity there? Then you've got these disgusting languages. The less said about which, the better. Moving on. And then, friends, you've got JRuby and Ruby. Friends, JRuby is Ruby in Java, and Ruby is Ruby in C. And yet the Java implementation is very clearly almost a third more efficient than the C implementation. When people say that Java is inefficient, they're lying to you. They've never tried it. They don't know what they're talking about. Java can do whole world optimizations that you just can't do when your code consists of malloc and free, little memory burps, okay? Java's an amazing boss sauce piece of kit, and it's an amazing place to run code. And then, of course, there is Python. Friends, that's 75.8. Round up, 76. What is 76 divided by 2? Again, I'm not great with math, but you know who is? Freaking Python. So let's try that, okay? So we'll go here. 76 divided by 2, 38. That means that if you wrote a program in Java and that program resulted in carbon in the atmosphere that in turn killed one tree, that same tree would kill 30, that same program in Python would kill 38 trees. That's a forest. That's worse than Bitcoin. We need to have a conversation about this. It needs to get better, particularly with the rise of AI. Anyway, moving on. So we've got this incredible runtime, but it could be better. And one way to make it better, Java that is to use the GraalVM native image compiler. So I'm going to go ahead and kick off a native image compilation here, okay? And I'm going to do that by saying Maven skip tests, because I didn't write any tests. Native compile, okay? We're going to let that do its thing in the background. And the only problem with GraalVM native image compilation is that it does take a while. It's actually doing analysis on all the code in the system and finding all the places where it's using a type explicitly, and then it's pruning everything else. The result is that you get this really, really comprehensive analysis of all the code in the JRE, the library, the class path, and your code base. But it does take a while, long enough, in fact, that now I kind of get bored, and I finally understand this famous XKCD cartoon about compiling. The number one programming excuse for not doing your work: oh, my code's compiling. The boss says, hey, get back to work, compiling. Oh, carry on. I get this now. I finally understand it. I didn't want to understand it, but I do. And it's gotten to the point where, frankly, I hear music in my head as I sit there fidgeting and waiting for the compilation to happen. I hear elevator music. So I went to Oracle and I said, hey, Oracle, please play elevator music during the native compilation process. I said, I already hear elevator music in my head when I do these long-running compilations. I'd just like everybody else to hear it too. And I got some great responses. But my favorite was down here. It's from Dr. Fabio Niephaus on the GraalVM team. He's a researcher and a doctor. And he says, thanks for your request, but it would just fix the symptoms. And they're trying to fix the cause. Okay, you go on. He says, anyway, I have prototyped a -- Josh Long mode. So you'd use the native image compiler. It would play music for you. Don't let the fact that this is an image preclude you from hearing the music it's playing. Then you'd see music brought to you by Josh Long. You're still waiting for the thing to finish. So now you have something to look at as well. Genius. I'm sure that'll get merged any day now. What were we talking about? Oh, right, the compilation. So if we go back here, yeah, it finished quite a while ago. Let's go here. Service. So I've got this binary. Okay. Service service. I'm going to go ahead and run it. Boom. Okay. Oh, port. I've got the other Java process is still on that same port. Let's go here one more time. There you go. 0.1 seconds. And if you look at the RAM, friends, if you go up here and look at the process identifier, PS-O RSS, it's the divide, that's in kilobytes, so divide by 1,000, 118 megabytes for an application that talks to the freaking singularity, that has unlimited virtual scale. You have AI, you've got nice clean code, very, very concise. It's an amazing time, my friends, to be a Java and Spring Boot developer. I hope I've so persuaded you of this. Thank you so much for your time, and I hope you have a wonderful day. And I'll happily take questions now.
Wow, Josh, just wow. We just had praise. I don't know if we had any questions. We had incredible praise from the audience. The live demo had that one issue with your Postgres. We had some people trying to solve your issue there, saying ports, fix the ports there. Maybe it's the JDBC URL on or that. There are no questions around that. But who doesn't like a good live demo that someone really manages to fix live on air, though? So there's no greater feeling. It's like watching a Christopher Nolan movie and the guy goes backwards in time and Tenant. Okay, I didn't really understand Tenant to start.
Nobody does. Well,
but
that's
wow. Yeah, we actually have Daniel. I was just chatting to Daniel on the side, and I said,
Hi.
Daniel's Josh is doing some of your talk now on virtual threads.
Yeah, I was afraid he will cover it all.
He's doing the next session. So I want to thank you, Josh, and I want to introduce Daniel, who's going to be speaking on virtual threads. Josh, safe travels back home, and thank you so much. Incredible session.
Thanks, everybody. Have a great day. Bye-bye. Bye, my friend. Bye, Rory.
Daniel, so virtual threads, which is a game changer, like Josh said, on the cloud, it saves you money. It really does. And you and I were chatting that it's a great eloquent way to do streaming and to do reactive streams with that, though. So you're going to show us today the basics, the nuances around it. Just before, I want to just remind everyone to please do the survey. We really want to hear you from that. So JDConf /survey. And then I want to hand it over to you, Daniel. You've got the audience. You've got the floor. Over to you.
Cool. Let's start then. Am I on? Awesome. So, welcome. I will try to cover the parts that Josh didn't get to with virtual threads in action. So we'll put them in some action. My name is Daniel Katz. I work in Oracle. I'm a Helidon developer. You can find me on Twitter and all the other usual social networks. On Medium, I do some articles from time to time. Blue Sky and GitHub, it's a usual handle. The agenda is for the next 22 minutes will be the quick Helidon introduction. We will take a look what action we do in Helidon, where the virtual threads are particularly great at. How we did it before we had virtual threads with reactive approach. We will do a quick introduction to virtual threads, when Josh already covered some parts of it, so maybe we'll hear it twice. How we do the action with the virtual threads in Helidon 4, this is the important part. And if you have a time, we will take a look at Achilles' heel of virtual threads and what to do with it. So let's start with the Helidon introduction. What is Helidon? Helidon is a microservice framework. It's a web server built to play nice with Kubernetes. And to describe it best, it's our main competitor is the Spring Boot. So it's basically the same thing. We do keep our number of third-party dependencies as low as possible. It's a big difference. So you don't download the half of the universe when you are building Helidon up. And you can choose from you can choose your path with the right flavor of Helidon. We have two flavors of Helidon. We have Helidon SE, which is a micro framework. There is no magic in it. There is no injection. It's just a pure performance with builders and lambdas, and you get what you write. So you have total control over everything. Then we have Helidon MP. That's quite the opposite. It's annotation driven. It implements microprofile specification, so you get Soares annotation and CDI, and it's very easy to use. Helidon MP uses Helidon SE under the hood, so you get the Helidon SE either way. But with MP, it's just adding all kinds of magic, so you can concentrate at your business code, and you don't have to tweak around some performance switches needlessly. Here's the example of the difference between those two APIs, between those two flavors. This is simple HTTP get hello world resource in both flavors. On the left, you can see the Helidon SE. On the right, you can see Helidon MP. And when I say resource, the Spring developer would say controller, I guess. You can see the SE builder pattern here with Lambda returning the usual hello world, while on the right side you can see exactly the same thing with Soares annotations. We do provide 3 ways of packaging Helidon application out of the box. We do provide, you can do a thin jar, which is a small application jar with just the business logic in it. There is nothing else. And there you get the lib folder for all the dependencies, even the Helidon itself. It's in the application jar is only your business code. This is very cool for nice Docker image layering, because when you change your business code, you don't have to push again the layer with all the dependencies to your Docker repository. You can push only the small changes, and the dependencies can stay there, and you don't have to have so much traffic around. Then you can very easily do the J-Link image with Helidon. J-Link allows creating a minimalistic, custom-tailored Java runtime just for your application. It understands the JPMS modules and does the tree shaking based on it. And by the way, all the Helidon modules are JPMS modules. So if you want to go with the module path, you are completely safe with Helidon. We are the first class citizens in this environment. With J-Link image, you also get like a 74% size reduction. Well, I have calculated this number when I have J-linked our greet example, which is basically a hello world. How I get the number is that it was the JDK plus the application was around 340 megs. After the reduction, I got image size which was 88 megs, and that this image doesn't need any JVM, additional JVM anymore in the container. So you copy into the container only the image and run it as it is. So you don't need any complicated thing anymore with your Docker. You just copy in the image. And the third but not least, the GraalVM native image. We optimize our modules to be compilable with the native image. So you can create very easily the native binary with super fast startup time out of your Helidon application. It has more advanced tree shaking, which does not depend on the JPMS modules. So with our greet example, I got like 88% size reduction. That was again like 340 megs JDK plus the application, and the resulting image size was like 41 megs. So it was pretty cool. And again, you don't need any additional JVM in your container. So you just copy in the executable and you are good to go. All options are easy to use with containers. That's what we do. We are doing it for Kubernetes deployment. And what action we do for you in Helidon? Well, we optimize concurrency. That's the main problem we do solve. When you use Helidon as a web server, the concurrency behind the scene is always high. Users need to be able to call other systems from handlers we provide, like database, messaging, HTTP calls, etc. Helidon server needs to respond fast, so we are working hard for our users to have as much CPU CPU cycles and memory as possible, saved by utilizing resources very effectively. And why is optimization so important? Also, Josh already told you that it's the cloud age. Your managers can directly see how effective or costly your applications actually are. So less pods for the same amount of work means less money you need to pay to your cloud provider. Helidon gives you a great head start in this direction. And servers in general are dealing with some heavy concurrency. The JVM specification doesn't actually state how Java threads should be mapped to operating system thread. And so far, Java threads was just a wrapper around the kernel thread, mapped one-to-one. But starting the kernel thread is expensive. It's done by actual system call. So every kernel thread created by JVM needs megabytes of memory. And that's not the end of it. There is also a context switching. That's the situation when you need to offload the blocked or waiting thread of the CPU, so some another physical thread can take on and work on its own stuff. And with all that megabytes of memory in the context of your threads, it's quite expensive. It gets even more expensive with more threads already started. So more physical threads you start, the context switching is more expensive as everything slows down and it's worse and worse. What we have done about it so far, we had thread pools. We have been reusing the threads. We didn't start them too often. We didn't start too many of them. We've got used to, we have got used to thread pooling. That's how WebLogic done that for quite some time now. And that's not the only trick we have used. We have also figured out how to avoid the blocking the thread by keeping the threads busy, by organizing the tasks for them in such a way that no blocking is actually needed, to minimize the context switches. And how have we been doing that so far? After the thread pooling, the reactive programming came to save the day. Reactive programming is a way how to avoid blocking, thus avoiding the expensive context switches. To do that, the code needs to be asynchronous. Don't let our thread wait for something, continue to work on something else. Response or result will come by callback on someone else's thread. Means that instead of blocking, you just provide a callback function. But by ditching blocking, we have lost the natural back pressure. We can't control how much data comes back on callbacks. The callbacks are executed on different threads. No one is waiting on anything. The order of execution is, well, there is no order of execution. All those race conditions are just waiting to happen. But luckily, we have reactive streams operators for callback orchestration. Reactive operators are implementation of reactive streams API, which is a set of APIs for orchestration of callbacks with built-in back pressure mechanism already. It is an attempt to bring order to the callback hell by a set of very, very strict rules. And it's even part of the JDK since Java 9. You can find it in Java util concurrent package in a class named Flow. But while the interfaces seems to be fairly simple, the specification rules are ridiculously complicated. So complicated that when you try to implement the interfaces yourself, the IntelliJ IDE actually warns you off. Don't implement it yourself. Rather, use already existing libraries, providing reactive primitives with operators implementing reactive streams in a builder-like pattern, usually. There is well-known RxJava from famous David Carnock. There is Reactor from Spring, Akka Streams, the service stock from Apple. We have our own operators in Helidon. Those were also contributed by David Carnock. And for example, in Quarkus, they have Mutiny, which is also very interesting. They have little different API. It's a different approach, but it's also very interesting to try on. Now we have established that reactive operators help with complexity of asynchronous code. Well, do they really help that much? They do. a little, but it's still a trap. The reactive programming has a steep learning curve. It's a maintenance nightmare. The debugging is hard. You are not going from up to down when you are jumping into your debugger. You are jumping all around because there is no order of things. The stack traces are practically useless. Blocking or obstructing code needs to be offloaded to some extra threads anyway. Otherwise, terrible things are bound to happen. And the reactive APIs are infectious. Once you use them on your API, you will never get rid of them. It's a trap. But luckily, there is something better. In September 2023, with Java 21 release, the JEP 444 delivered Project Loom. And Project Loom covers mainly the virtual threads, the structured concurrency and debugging support. Now with virtual threads, you can choose if you want to use platform threads or virtual ones. Blocking operations don't cause expensive context switches anymore. We can have a huge number of virtual threads, and it is cheap. The stack traces make sense again, and naive imperative programming is safe and performant. Virtual threads have the same effect for avoiding context switches like reactive programming has, but it doesn't pollute your code anymore. It happens behind the scenes. Before somebody asks, we had something similar in Java before. It was called green threads. And those were user threads working on top of a single physical thread. Back then, computers had usually a single CPU. There was an exception on Soares, JDK, but that's very interesting, but different story, and I won't fit it here. And green threads were replaced eventually by operating system threads abstraction to allow the real multi-threading instead of multiplexing on top of a single thread. The virtual threads, on the other hand, always use the multiple physical threads as a carriers, so you can squeeze power from all your cores. Unpark of virtual thread actually schedules continuation to be run by one of the carrier threads. The scheduler here is actually a forging pool. And those are continuations under the hood. For example, let's see how thread sleep actually yields and park continuation. If you look inside the Java-lang threads class, you can notice how sleep method does something else for virtual threads since Java 21. If you inspect the virtual thread sleep nanos method and follow the rabbit a little deeper down the hole into the park nanos, you are going to find a yield continuation. And that's because virtual threads are continuations in Java. And if you want to know more, there is a great session done by Ron Pressler on YouTube. You can find it if you look for continuations under the covers. And it's a nice and very deep explanation what happens with the thread stack, how the virtual thread scheduling is done, how it is actually a forging pool behind the scenes, and so on. So if you want to go a little deeper and figure out how the virtual threads are actually doing the stuff they are doing behind the scenes, this is the great way to go. Now, when we know what virtual threads are and what they are good for, we can take a look how Helidon 4 puts virtual threads into the action. And what we did in Helidon 4, we got rid of all the reactive stuff from our web server. We got rid of Netty. The Netty is well-known and very powerful library for working reactively with sockets in Java. But we don't want to work with them reactively anymore, do we? We have created a brand new web server, fine-tuned for virtual threads from socket all the way up to your handler. Removal of Netty allowed us to get rid of all the reactive APIs. Our brand new web server with secret code name Nima is clean, fast, and optimized for virtual threads from ground up. You can see here how Helidon MP APIs did not change at all. Just Helidon SE APIs are imperative, and blocking code is embraced. But Helidon MP stayed as it is, because it was imperative before. It was just on top of the reactive Helidon SE. Is that a big leap for a framework like Helidon? we do leaps like that. If you take a look at the history of Helidon releases, you can see that we do such things to keep our users on the edge. So each release of Helidon is somehow revolutionary. While Helidon 1 was on top of JDK 8 and it was asynchronous, it has some reactive APIs. Helidon 2 switched to JDK 11 to support reactive streams API added in JDK 9. And in Helidon 3, we switched to JDK 17. And why we switched to JDK 17? Because we already supported experimental virtual threads usage. And but we did it in a way like most of our competitors are doing it right now. We have been offloading to the virtual threads from our reactive web core. We also implemented Jakarta 9.1 with Jakartified packages and so on. So there were some big changes in Helidon 3. And in Helidon 4, we switched to JDK 21 to fully support virtual threads. It came out shortly after the JDK 21 release. The netty is gone, and virtual threads are used in thread per request manner right now. And performance, we are doing good. This is a well-known tech and power performance benchmark. In the last round, the Helidon 4 with virtual threads has proven that the reign of reactive has ended, with performance of imperative code on par or even better than our competitors, while keeping your code simple to understand and maintain. There's no reactive madness anymore. And with no reactive layer, when we say that we use the virtual threads in Helidon now, there is no offloading. There is no retrofitting. This is what our competitors are doing. With Helidon 4, it is a virtual thread per request in a web server built specifically to work best with virtual threads. Also, we are optimized for Java sockets with virtual threads. We get faster and faster each time the new release of Java arrives because they are optimizing the Java sockets for the virtual threads all the time. Also, in Helidon, you can't just turn off the virtual threads. Everything is virtual threads by default. It cannot be turned off. If you want to use a platform thread, you have to actually offload to it. So it's other way around. And as a bonus, we got rid of a lot of security issues coming with netty. That was nice. And is there any downside to it? There is a known issue with virtual threads when carrier thread gets blocked together with virtual thread. This can happen, for example, when Java synchronized is used for locking, or when locking is done behind the JNI interface. There are a few use cases when this can be a problem. The usual suspect is synchronized. It's not always harmful. The short-lived in-memory operations with synchronized are not harmful at all. In case of pinning, carrier thread pools compensates by spinning additional carrier thread. So this doesn't immediately break horribly. This just leads to some performance degradation, but it still works in most cases. The reentrant locks don't cause the pinning. So reentrant locks are virtual thread friendly. They are safe with them. Now we can take a look at example I have here. We do there a simple sleep in a synchronized block. As we already discovered a few slides back, the sleep is actually yielding continuation on virtual thread, but this time the blocking happens in synchronized, and there is no alternative logic for virtual threads available. We have two options how to detect pinning. First option for pinning detection is with property JDK traced pin threads. You can see exactly where the pinning happened in the printed stack trace. It gets printed when the pinning happens. With property set to value short, you can print just the problematic frame. This approach is not recommended for production use with Helidon because printing to system out with this type of contention can be quite problematic. So there is a better way how to detect pinning. Let's rather use a second option, which is a Java flight recorder event. The event is called jdk.virtualthread_pinned, and it's very easy to use because it is enabled by default for operations that takes longer than 20 milliseconds. As we can enable it explicitly in our example and dump GFR recording to file to inspect it later. In the recording, we can find the same information about where is the pinning crime being committed. And what about synchronized? Do we need to stop using it altogether? Well, frameworks and libraries are replacing synchronized to claim virtual thread friendliness already. For example, MySQL, Oracle, or MongoDB clients are already synchronized less, and they can claim, therefore, that they are virtual thread friendly. Also, a lot of synchronized usages are being eliminated in runtime or are not causing pinning issues at all. And most importantly, the pinning class synchronized is close. We in Helidon team already got access to internal JDK prototype built already, so hang tight. Even more goodies are coming. And remember, in comparison with accidental blocking in reactive code, the pinning suddenly doesn't look that bad. And that's about it. It's all from me. I hope you like the way we have put virtual threads in action with Helidon. Come and try. We are 100% open source project. You can just download us for free and try to build your app with us. You can find us on Twitter. We have a blog on Medium, great web pages with documentation. We even have a YouTube channel, and we are YouTubing sometimes. And we can help you with your issues on our public Slack channel, or we are also monitoring the Stack Overflow for the Helidon tags.
Thank you so much, Daniel. Incredible talk, and I learned a lot about it. But the most interesting thing is you solved the problem that I actually had with the pinning, because I also encountered the same issue. I was creating the virtual traveling salesman problem, and I couldn't actually get the threads to interoperate in a certain way, though, and I didn't even realize that pinning mechanism was available. So I'm going to jump on and try get it working with Helidon, and I had at the time used Spring Boot though. So let me see if I can actually get it working though, and maybe you'll convert me into that though. Do you see virtual threads really being a part of this whole AI revolution? Because AI this, AI that. And one of the things about AI is it just consumes resources. It really does. It just burns through resources and credits and money, actually, in some ways, though. And optimizing of costs is pretty important, though. What is your take on that?
Well, first of all, you are not only optimizing the costs of the CPUs being burned in your cloud, you are also optimizing the cost of the developers, because to train a developer to be effective with the reactive APIs is very expensive. You have to be quite senior, understand the concurrency very well, and again, the learning curve is horrible for the reactive. So if you don't have to do that, if you can stay imperative and go from line 1 to line 15, then all the problems you are solving are suddenly way cheaper to solve if you take in the salaries of the developers. So it's not only the hardware you are saving, you are also saving the minds of the developers, and they can learn more about how to use the AI and prompt it correctly, right?
I agree, because like I come from a threading background, and then Lambdas came about and streams, and I was like, oh my gosh, what are these monads that I have to learn how to do? And it kind of blew my mind. And then virtual threads came about, and I went, did I need to even know about that and everything? So Java developers coming on now have it really easy, because they don't have to learn sync await with basic threads. They can learn Lambdas if they don't want to, and then they can just go straight into virtual threads. So it's an interesting time to be a Java developer. Daniel, any other call to actions before we bring on the next speaker?
Yeah. Let's try Helidon. It's you can compare it with Spring, how we do the virtual threads there, and what's the good and what's bad.
Great. Thanks. Thank you so much, Daniel. I do see that we have our next speaker available. I think that they are online. So I want to ask the team, else we can wait a few more minutes though. We can take a few more questions. I do want to just remind you about the Java Cloud Skills Challenge that we have online though. So if you want to bring on my screen, this is the JDConf challenge here. So if you go to aka.ms JDConf challenge, and like I said before, this is very important for not only your career, but it also shows your stakeholders, your enemies, if you have any, that you are relevant and you have experience. And one of the things that we have on that is the Azure OpenAI session, the learning material there. So we have an incredible lineup there. Go in there, post your changes, go in Twitter, and then make sure that you feedback to me. You can reach me on Twitter at Rory Preddy. I'll retweet you. You do it. You finish that Cloud Skill Challenge. I will retweet you to the tens of thousands of people that have nothing better to do but to follow me. Okay, so we do have our next speaker here. I want to bring up Manesh, if you can though, and we have Manesh Sharma, who is I work with actually on a good day. Manesh, welcome. We've had some incredible speakers today. We've had Josh Long, we've had Daniel speak on virtual threads, and now we've got yourself, and you're going to be speaking on complicated topic. I can't. Building generative AI applications with Azure, Cosmos DB, and Java. And I love Cosmos because Cosmos, you can just get stuff done, and it changes according to your requirement. You can use it as a NoSQL database. You can use it as a relational. And now you're going to show us how to build generative AI applications, which is the hot topic of today, though. So, yeah, if you want to give yourself an introduction, if you're ready to start, let's do it.
Cool. Thank you so much. I hope I am audible. Am I audible?
Hi folks, Brian Benz here, Cloud Advocate at Microsoft, welcoming you to another JDConf 2024 on-demand session. In this session, Timo Salm, who's a senior lead Tanzu DevX solution engineer at Broadcom, is going to cover going serverless with Spring support for GraalVM, Project CraC, and more. In this case, the and more is class data sharing. He covers GraalVM, he covers coordinated restore at checkpoint, which is CraC, and also class data sharing. And the whole idea behind the session is to help you improve the performance and scaling of your serverless applications using the packages I just described. Pretty cool demos. Please check it out.
Hi, welcome to the session about going serverless with Spring support for GraalVM, Project CraC, and more. My name is Timo Salm, I'm a pre-sales specialist for developer experience for the VMware Tanzu portfolio at Broadcom. And if we have a look at the agenda, I will first introduce the topic with some slides about what serverless is, and then I will show hands-on different technologies to actually improve the runtime efficiency of your Spring applications to be able to run them on a serverless runtime. Like, for example, GraalVM native images, JVM checkpoint restore with Project CraC, and also class data sharing, and then I will wrap everything up with a short summary. So, what is serverless? Actually, serverless doesn't mean that there are no servers, it just means that you don't have to care about them. And it can be grouped into two areas. So the first one is backend as a service, where you replace server-side self-managed components with off-the-shelf services. A good example is, for example, instead of managing your own authorization server, that you use a SaaS service like Auth0. The second group is about function as a service, a new way of building and deploying server-side software oriented around deploying individual functions. And for sure, for example, also get all those benefits of serverless runtime. These functions, they should be stateless, or in general, all the applications you run on such a modern infrastructure. The key about both areas or groups is really that you don't have to manage your own servers or hosts and server process, and therefore can really focus on business value. The outcomes of serverless is that you actually have a shorter lead time because of the fact that you don't have to care too much about the packaging, and the deployment is a lot easier. So it actually provides a high abstraction for you, and you don't have to care about all the stuff that's happening underneath. The next thing is really about the increased flexibility of scaling. So usually on modern infrastructure, like for example also container runtimes, etc., and the scaling is horizontal instead of vertical, which means that instead of attaching more resources to your virtual machine, you scale horizontally, so just creating more instances. And for that, it's a huge requirement that those applications that you run in those different instances, that they are stateless, so they only share a state via, for example, databases, etc. The next thing, which is also a little bit about that flexibility of scaling, and especially scale to zero, so not having any instance running if there's no demand for it, is about reduced costs for the resources, and also labor costs, which means that you don't need all the people that are managing your full stack if you have, for example, a SaaS service, serverless runtime, like for example Azure Container Apps. The next thing is also about the fact that other people are actually managing all your infrastructure stack, so you have reduced risk for that, and also you have in a way reduced risk with that horizontal scaling, which means that you don't have too much downtime, because if one of the instances crashes, there in best case are additional ones, or especially with optimizations we will see later, it's easy, or automatically there will be a new instance available that takes on the traffic. But usually, if you have a solution that provides some outcomes, there are also some drawbacks and limitations. And with serverless, there are a lot of limitations, but it also provides a lot of outcomes. And for sure, one of the limitations is, or other unpredictable costs. For sure, it's possible, especially at SaaS services, but also technologies like Generative as a serverless runtime that can run on any Kubernetes, that you can define some boundaries. So how many instances you want to spin up as maximum and also minimum. But in general, that's one of the drawbacks. It's also like one of the drawbacks that we will, or you will probably identify, and we will see in a minute with the Java applications, is the startup time. So if you have, for example, scale to zero and your application takes 0 seconds to spin up, it could be that request timeout, which is not great for the user experience, and for sure it has to be handled also on, for example, the front end side. Also, the fact, which I already mentioned, that serverless applications in most of the cases are stateless. So it's the state will be not stored on the disk, and instead maybe in databases, which also means that there's a need for a lot more baking services that legacy applications actually had. The next thing is maybe a vendor login. So if you're using a solution like Azure Container Apps, there's not too much of a login, because you have a container and you can also deploy this container to a different solution. But if you're, for example, packaging your application or writing in a different or special way for a solution like AWS Lambda, it's a different story. But there are also then solutions available, like for example Generative, that are completely open source and run on any Kubernetes. That's something we will use today. So Generative as a serverless runtime on top of Kubernetes. Another drawback is that, for example, the loss of control over all the stuff you're not responsible for managing anymore. So if there are any problems, you really have to rely on the provider of that service. And there are several more, like for example, the higher latency due to the communication, especially if you have an application that's built with functions, also microservices, because there's a lot of communication happening instead of having everything in one application where you don't have any latency between the calls. And for this session, I'm using a really basic application to which will already show all the benefits that you can achieve with those different technologies focused on runtime efficiency. And for that, let's first just run this application without any optimizations on a serverless runtime, so Generative. And for that, I will go to my terminal here, because of the time they are already deployed. So let's do kubectl get k service. So that's the name of the Generative custom resource. You can see that's our hello world, and we can use service. What we can see is mostly that's a container image which I've already built, and you can easily use in Spring since version 2.3 the built-in cloud native build pack support, so that you don't have to create a Docker file, and the build packs, they will recognize, oh, it's a Spring application, and build a container image with best practices for you out of the box. In this example here, we're using Gradle, and the Gradle command, for example, is Gradle boot build image, providing the image name, and then the plugin will do everything for you, and you can then push this container to a container registry. That's what we already did. We reference it here, and you can also see some additional capabilities in this service specification which are added after I applied it, like for example traffic splitting, etc. And if we have a look at the pods, so where those application is running on, you can see they're 0, because by default it's configured for scale to 0, which means that you're not, especially on cloud services, but also on the infrastructure energy-wise, you're not you don't have any cost for the stuff, because you're actually not using anything. But if we now run a curl for our application, that actually we now have a response. And if we have a look at book pods, you can see, oh, it's there. if we have a look at the logs of our application, we can see that it took 4 seconds to start this application. I said it's really basic. It's just one REST controller that's providing that hello world message, and we have a startup time of 4 seconds. You can imagine if you have a huge application that it's around 15 or 20 or even longer, which means that those requests, they will time out, which is a problem. For sure, you can pre-provision stuff, so it's also something I can do with Generative or with other Azure Container apps, but then you still have costs even if there are no demand. So because of that, actually, what we should do is, we should see how we can optimize our applications. And that's actually something then we should really do to actually save more costs with the serverless runtime. So first, faster startup time and also the memory consumption. So if we run kubectl top pods for our application, I hope it's still there, we can see that we are actually consuming 200 megabyte of memory here, which is also, if you have a really small application, a function, a lot, especially if you have a lot of functions, and you scale them to hundreds or thousands of instances. So that's something we want to improve. And actually, for that, there are several technologies available nowadays. One of the first ones is GraalVM native images. And if we have a look at GraalVM or native images in general, what it is, actually it's like standalone executables of ahead of time compiled Java code, which means that instead of running the application on a JVM with a just-in-time compilation, which we see here on the diagram, it's like usually you have a compiler that creates transforms your Java classes into bytecode, and then you have the Java file, and on runtime the bytecode will be run with an interpreter. And to optimize the performance of frequently used paths in your application, there is a just-in-time compiler which compiles specific parts of the application into native code, so meshing code, which then speeds up those frequently used paths, for example, endpoints or API endpoints. With ahead of time compilation and native images, it's different. So actually the full code will be first compiled to a bytecode, but then on the build phase created as a native image. So machine language based on actually the architecture you build it on, which is also a limitation. And with that, you got a really huge improvement in, for example, startup time, etc. Because all the just-in-time compilation, etc. It reduces a lot of resources and also adds additional startup time. With that, we can really improve the startup time of your applications. And everything this application needs from a JVM perspective is still available, packaged together with something called Substrate VM, so that everything the application needs, so all the classes, etc., are in this one executable. And it's also like that, for example, things, the class path is which you could change if you run on JVM, is fixed, etc. So it's really like package everything that you need for the runtime into one executable and not being able to add stuff dynamically. And GraalVM, as that, is an advanced JDK from Oracle that is really supports this ahead of time native image compilation. So let's now have a look and run our application. It's also possible, just for information, to build a native image with those build packs that are coming out of the box with Spring Boot. Only thing you have to do, so for GraalVM it's the same command, you just have to add this Graal plugin here. And with that, the command, the build image command, will create a native image. As that, keep in mind that if you do that, the native image will be created based on the architecture you have. So here I have, for example, one M1 Mac, so an ARM processor, and therefore this native image will not run on my Kubernetes cluster, which is based on a different architecture. For Maven, for sure, the same is also available, but there you, after adding the Maven plugin, you have to specify a profile, so profile native for the build pack, and also for the Maven plugin to do it without, which is for sure also possible without directly building a container. That's a little bit different here from the experience. And what we will do now, as said, I already deployed everything, so we also have a knative service here. So we can see it here, it's hello world native, and if we run our curl command to provision to start, and if we run our curl command to start our first container, we're able to see how much we were able to improve our application by actually just compiling it to a native image. We can see that the startup time, instead of around 4 seconds, is only 169 milliseconds. Without changing anything here in the application. So an amazing improvement. And if we have a look at the memory consumption, we should be also able to see some improvement. So we can see it's only 40 megabyte instead of around 200, and also from a CPU side, it's half or a third from the resources used from CPU. So really technology that helps us to make our application serverless ready, and we can really see the benefits of it, especially if we have scaled to 0, as you saw, based on how fast we got a response. But as always, there are unfortunately trade-offs, and one of them is the developer productivity. So because of the time I didn't show you how long it takes to build a container image or a general native image, actually it takes a lot of time compared to your usual build time. So really, instead of, let's say, 30 seconds, it takes 10 minutes. So that's a huge problem that is not really solved yet. So there is something available if you want to, for development, so not for production, but for development, that you can speed it up, because there will be not too much optimizations, and therefore also the startup time is not that amazing, and also the size, but it's like it helps you to validate whether the application works like it should be. For developers, that's available, but for production, it takes a lot of time, and therefore the recommendation is, for example, run this newer mode from developer perspective, or also just do ahead of time compilation without building a native image to validate the application works on your machine, and then delegate the building of the production-ready native image to a CI/CD pipeline, which, based on your architecture, is also something more or less required. A huge issue with the GraalVM native images is because of the fact that everything that you execute from a JAWS perspective has to be in the native image. It's not possible out of the box to use dynamic features without giving the GraalVM compiler hints which you would like to use. So they also have support for example, running specific parts of your application, and based on that, creating configuration files that you then give the compiler, that it includes those files. But actually, it's a lot of effort usually involved, mostly for custom code, because there is all the libraries for sure that are commonly used try to provide the support out of the box. And there's also a huge community around it for those that didn't do that yet, to provide those from a community perspective. And it's about dynamic Java features like, for example, reflection proxies, but also resources. The next thing is that, from a Spring perspective, to actually get the benefits of the static analysis, some assumptions have to be made, and in a way, you have restrictions. And that's really about the fact that the class path is fixed, and also bean conditions are fixed, and also, for example, profiles are not supported. So as I said, it's really about, okay, you have to actually decide which you want to run on the build time, and then you can actually run that on production. For sure, if you're using profile to switch things between different environments, which depends on whether it's a good idea, other than just configuration, because usually you want to test in a test environment what you would later run in production. That's not possible without building different native images for different environments. And so for those custom hints, those are usually files that you pack together with the application code. But Spring provides additional support here with the so-called runtime hints registrar interface, where you then support, you can see examples here for reflection, resources, etc., for those dynamic features you are using, and actually how you use them, and then Spring will generate those files for you, but you can also do that manually. For most of the classes that need binding, like for example JSON serialization, that's automatically done for you. But actually, if you're using directly web client or a REST template, you can also use the register reflection for binding annotation. And for sure, if you don't include something and, for example, have good test coverage and run your test, you can immediately see that it's not working, and then you can, based on that, provide the hints that you need. Okay, so let's have a look at the next technology that we have. So it's a newer one. It's called JVM Checkpoint Restore with a project CraC. And what's Project CraC? So CraC means Coordinated Restore at Checkpoint. It's an OpenJDK project initiated by Azure, as far as I know. And actually what it does, it provides a Java API to create a snapshot of a Java process when the application is fully warmed up, and also those optimizations I talked about. If you frequently a request or run a specific path in your application with a just-in-time compilation, etc. There's additional optimization happening, and you can then create a checkpoint and restore it later on, so with a new instance, etc. And with that, you get huge startup improvements with all the optimizations that you do on the training run. And the big benefit of that is that instead of with the GraalVM approach, here you can still use all the dynamic features, etc. It's just like stopping your application and restarting it. Unfortunately, you have it can be that you have to do some optimizations regarding a Java program, but the CraC library provides support for that, and also from a Spring side with the lifecycle start and stop capabilities that you can implement. You can provide the necessary code, and the thing is that to create a checkpoint, all for example open sockets, etc. have to be closed and then to be restarted after the checkpoint. And that's something, if it's not done out of the box with those typical life cycles in Spring, you have to provide. So it's also time for CraC demo. So let's have a look how the results are. So let's first curl it. It should also not take too long. And if we now run kubectl get kubectl logs, see a startup time of 169 milliseconds, so really close to the GraalVM native image. If we have a look how to get it running, you can see here that I added one dependency, so that's the CraC library, which is required. For sure, this one then is not required. And additionally, there are several ways on how to actually create or where to create a checkpoint and do the restore. So in this sample here, I'm doing the checkpoint on the build phase. So in my CI/CD pipeline, for example, via Docker. So I'm first building my application, as you can see here, and then I'm adding all the files I need, and then I have this entry point script that's actually doing the magic. So you can see, based on whether it detects there's a folder with all the checkpoint files or not, it will do a checkpoint or it will run the application from the checkpoint. And that's all stuff you can get from the documentation, but actually you can see that here what I'm doing is I do this CraC checkpoint 2 with a directory and my jar file, and then I wait for 30 seconds, and then I run because my application just provides an API endpoint at this default path here, or root path, and run some curls, actually request against the application for the optimization regarding that path. And then there is, that's what CraC provides, there's a command to actually run this JDK checkpoint command, which will shut down, as said, all the, or close all the connections, shut down everything, do the checkpoint, and then restart the application. And then just waiting for some time after it's created. And then from a startup or runtime perspective, there is the CraC restore from with a folder that will then actually restore this checkpoint. And with that, we really get those benefits. One thing I have to note here is that one problem also is that you actually need some privileges there. So you can see that I have to set some Linux capabilities to restore my application. So checkpoint restore sys ptrace and run as root. So that's an advancement compared to before, where you have to run it as a privilege, which is great. And it's also like you have to check that the Linux distribution you're running your application or also creating checkpoint actually supports those Linux capabilities, which is not the case until now for all. Also, you may have recognized that I'm using a special JDK here with a CraC postfix. So it's also something you have to ensure that you're, for example, from Azure, use a JDK that actually has CraC included, because it's not available in any in every open JDK or JDK yet. For the summary of the trade-offs, the first one is really that, the checkpoint, you have to start the application, for example, also in your CI/CD pipeline. You have to ensure that all the circuits are closed, etc., and restart. That's also something, if it's not out of the box available for all the functionality, you have to do yourself. One huge problem is regarding the checkpoint that first, for sure, you have to ensure, in best case, that your application is optimized for those typical paths, which is not, maybe after some time, you know which APIs, for example, call the most, and then you can adjust it in your CI/CD pipeline. But there's another problem, which is that it's, because of the fact that we're actually starting a JVM with everything set up and stopping it, for sure all the connections to the databases, etc., should be all, and also the production database should be in this checkpoint. Otherwise, it's we will not get the benefits, and therefore it's necessary, for example, to do a checkpoint against your production database for the image build for production. But the problem is that then in this checkpoint, you have all the information about the secrets. So this is also why we already tested a solution where we actually do the checkpoint on the runtime, so that you have one container image for all the environments, but you do a checkpoint, so with similar entry files that you saw in your Kubernetes cluster, for example. And then this checkpoint will be saved, or snapshot will be saved to a persistent volume or something else like an S3 bucket or whatever storage option. And then the other instances, so if you do autoscaling, they those snapshot is mounted to those additional instances, they will pick it up and start from it. So really doing the checkpoint and the restore on the runtime, that's the solution for that, but it's a little bit more complex to set up. But that, from my perspective, is the recommended way if you care about credentials, etc. And as already said, it's Linux specific, and you also it requires some Linux capabilities that are not available to every Linux distribution yet. So, and there's one more option, which is class data sharing. So what is it about? So actually, it's like there for a long time, more or less, and it's a JVM feature. It also reduces the memory footprint and the startup time, so like GraalVM. The thing is that it's continuously also involved, especially with enhancements in the upcoming project Layden, where it will be really also provide additional an enhanced version of class data sharing together with ahead of time compilation, and we have initial support for it in Spring Framework 6.1. It's actually not restrictive less restrictive compared to GraalVM and Project CraC, so it more or less just works. The only thing you have to keep in mind is like the improvements are not that high then with the other two technologies, and therefore it's maybe not the best solution for example, scale to zero, but it's a nice way with a minimal effort to improve the startup time and memory consumption of your application. If you, for example, have a lot of time similar demand and using it more for HA, etc. Let's also have a look here. And we can see here that it took around 2.6 seconds. So compared to 4 seconds, a huge improvement as that with a minimal effort, even if it's currently still like some effort involved. But that's also something we can maybe from a Spring Boot perspective optimize for you if there's interest in using it. And what I had to do to get it working is like that's hugely depending on as everything, because he's the lead of all that runtime optimization stuff, Sebastian. You can also see the source here, so if you would like to have a closer look. And actually, what it does is the requirement is that the jar files is unpacked in a specific format, and then there will be a training run with that Spring context exit on refresh. That's also something available for Project CraC to automatically do a snapshot. And what it does, it's starting the application, but not the life cycle, and exiting it automatically. And then we have those JVM properties, archive classes at exit to here, and as it's automatically exited, we'll just start, exit, and then provide all the information for the class data sharing functionality. And then on the runtime, we have the shared archive file to reference those. And that's all put together in the Docker file, so building the application, and then actually running the CDS script for the build, and actually using it. And if we have a look at this shell script also from Sebastian, we can see also how the structure looks like. But even it looks like a little bit complex for now. It's just about preparing the structure in a little bit different way, and the rest works without any modifications, which is really great. The trade-offs of class data sharing are mostly that the improvements are not that dramatic. One restriction currently is that executable jars. This is why we unpacked it, and unpacked deployments, which is a recommendation to run applications in production for also improved startup time. You can read that in the Spring documentation. It's not supported yet. But that's something hopefully will be changed soon from a Spring Boot perspective. One limitation is that the JDK and the class paths should be the same on the creation of the archive and the restore. Actually, the summary of all we did is that if you have faster startup times and lower memory overhead, you can really reduce the cost of your applications, especially if you have applications with a lot of users. It's not only about reducing costs, it's also about stability and high availability, because if one of the instances or several are not available with those huge or fast startups times, it can self-heal fast enough to not let your users run into timeouts. GraalVM native image is one of the technologies which provides the most improvements for startup time and memory consumption, but it has really constraints, especially about those hints you need for dynamic features and also the build times. The next technology, JVM checkpoint restore with Project CraC, so it's not that major, and provides similar improvements regarding startup time, but not for memory consumption. And it also has several constraints, and one of them is really that where you create a checkpoint, which I said about the leak of credentials, probably better on the runtime than the build time. And last but not least, we have class data sharing as one of the solutions. I think especially in the future with Project Lane, that will be really commonly used, but because of the improvements are not that dramatic than with the other solutions, not for scale to zero use cases, more like, improving the stuff a little bit. And if you have, I would say, regular demand and not too much peaks in too much peaks or scale to zero. And that's it from my side. Thank you very much.
Thanks for watching. Check out this and more at JDConf.com.
That was incredible. Now, we just had virtual threads, and we had some technical difficulties, so we swapped over to Project CraC, and at the incredible session of looking at GraalVM versus Project CraC. I love that we went head-to-head around it, though, and it's such an incredible time to be a Java developer when you can go scale to zero. So you can actually minimize your costs. And here with me in the next speaker is someone who's going to show you also one of my favorite technologies is the seamless deployment and execution with Azure Container Apps. Another incredible service to help you really make more scalable and cost reduction on your cloud infrastructure. And my colleague and friend, Sean Lee. Sean, how are you doing? What are you going to discuss today?
Hello, Rory. I'm doing well. How are you?
Well, it is 5 o'clock still, 5 a.m. in Johannesburg, South Africa. So I'm feeling a little bit vulnerable, but it's I'm all good. I've got my coffee. I've had my Red Bull.
Well, thank you for being early and running the show, Rory. Appreciate it. Should I get started?
Yeah, go ahead.
All right. So just very brief intro by myself. My name is Sean Lee. I am one of the product managers from the Java on Azure team. And today I'm very happy to talk to you all about running Java apps on Azure Container Apps. All right, so let's go to the slides. All right. So Azure Container Apps, or ACA as we like to abbreviate it from the product team, is a great platform for running generic containers. You can run applications that is built with any programming languages in the same Azure Container App environment without having to worry about the underlying infra, be able to scale to zero, as we've been trying to echo that message many times, and also share the same virtual network without a PhD in Azure networking, that is. Now, while it serves as a versatile platform, but when it comes to Java, we realize that Azure Container App may not offer the precise insights into your Java applications or the state of your Java execution environment, such as JVM. And my team is all about Java developers. So to better cater the needs of our Java-centric customers, we've recently embarked on a new journey to enable Java customers on Azure Container Apps. And here are the 3 value pillars that we have in our mind when we built the product. Starting from source to cloud, which is the first step to get your apps up and running in Azure. Now, in addition to .NET, we now also support source to cloud for Java. So you'll be able to deploy directly from your Java source code, as well as any Java artifacts. Once your app is up and running on Azure, chances are it won't run in isolation. This is where the managed Java components will come in, right? Now, these components do not provide any business value, but they simply need to be there for your apps to work. Let us manage those for you so you can focus on something that really matters. The third pillar, which is monitoring and troubleshoot. I want to say this aspect is often much easier to do in your local development stack, as you have all the tools and permissions to troubleshoot. But moving to the cloud, especially in a production environment, it is a different ballgame. Now, kind of transitioning from the value pillars to our Java roadmap slides. In the preview out in the market, we currently have build and deployment that we started public preview for those 2 earlier this year, and then in the month of end of March, beginning of February is when we made 2 managed Java components available in the market, and those are managed Spring Cloud Config as well as managed Eureka for Spring Apps. So we're going to take a look at the managed application config service today. In the month of April, we are heads down working on our monitoring and diagnostic features. And beyond April, for the later half of the year, is our main focus would be to GA the features that we currently have in the market. All right, so that's kind of our Java on ACA roadmap in a landscape. Okay. Now, so now we're going to delve into the first item we have on the roadmap, which is build and deploy Java apps. So we all know source to cloud provide a convenient way for you to deploy your Java apps to the cloud. But what is less talked about is that it also helps you to consistently build, maintain, and update images. And in doing so, also boost your security and reduce risks from CVE. Now, what I mean by that is I'm going to demonstrate that in this scenario here. Now we know one common practice is to containerize your Java application with Docker files. Now this practice not only introduces overhead, but also leads to inconsistencies. Imagine we have two teams here, Team A and Team B. They both have total freedom of the composition of their Docker files. In this case, Team A has picked a version of OS Ubuntu 20.04, and Team B has picked another base image from CentOS Stream 9. And in this case, we all know there was a pretty widespread OpenSSL CVE that took the world by storm last year, which is the case here. The Team B is in fact impacted by this CVE. So now to detect and resolve this issue, one would have to go through each Docker files and then manually rebase all the images that are vulnerable to the CVE. Now, so as a result, it's hard to update. It's uniformly challenging to keep images out of vulnerabilities. And the problem even gets more complicated by orders of magnitude with more teams joining the organization. Now, Azure Container Apps now natively supports building and deploying Java apps directly from source code, jar files, or WAR files. And then the input would go through the Azure Container App build process, and the output of that is an OCI compliant image deployed on Azure Container Apps. Now, so to address the issue that we highlighted in the previous slide, all we have to do is to issue an upgrade command, and the ACA cloud build process will rebase a new OS version uniformly across all apps. Okay, and this is what the build and deploy experience will look like in the Azure portal, and this experience will become available in a couple of weeks in the month of April. Okay, so when you create a Spring app, we will present you the option to either deploy from a container, or you can pick if it's a source code. If you pick it's a source code, then we then ask you where should we pull it from your GitHub repository. Okay. All right. Next up, we have managed Java apps. As I stated before, more often than not, your app will rely on other Java apps in the market for discovery, application configuration, monitoring, API routing, right? And chances are you're already running some of these today. So what you have probably done is you have to download the bits, build it, run it, and manage those components, similar to how you would run your other Java apps. And from our team, we really want to make this easier for you. So things like HA, version upgrades, patching, CVE are all taken care of as part of the fully managed experience. Okay. Now over here, I'm showing you a mock-up on what this experience is going to look like in the Azure portal. I'm actually going to cover this in the demo, but in the demo, I'm going to show you the CLI experience. But in the portal, what's going to happen is when you create an Azure Container App, we will present you with a list of managed Java components on the right. In this example, I'm picking the Eureka server for Spring, and to create the managed component, it is as easy as clicking the button and then binding the component to your Java app. Okay. Okay. Third, I want to talk about monitor your Java apps. So we know logs and metrics are incredible when it comes to monitoring and scaling your apps. Almost all Java developers we talk to rely heavily on logs and metrics to assess their application health and identify issues. Now, good news is Azure Container Apps is already natively integrated with Azure Monitor, but we want to take that one step further by giving you native Java metrics such as JVM, memory, GC, as well as Tomcat. Now, again, this is a screenshot of what it would look like when the Java metrics are available in April. Over here, we're showing you both JVM metrics as well as Tomcat metrics embedded directly into the Azure Monitor experience inside of Azure Container Apps. So you can then use these metrics to monitor your apps. You can set up alerts as well as use these metrics to set up scaling rules for your Java apps. Okay. And here's another concept where we provide a Java memory-centric dashboard to show you the amount of container memory that you currently have, amount of heap memory consumed, directed memories consumed, etc., etc. Okay. The last value pillar that I want to talk to you about is diagnostics. So we all know that Java application can often also suffer from availability and performance issues. Developers and IT administrators spend a lot of time diagnosing, getting to the root cause of these issues. And frequently, these issues cannot be easily reproduced or simply not feasible to reproduce in a production environment. Right? And all of this can have a severe impact on your life sites and business continuity. Based on our experience, we have identified several areas where errors tends to occur. These areas include memory issues, null-point exceptions, and deadlocks. So those are the areas we're going to get started to work on and solve it. Now, I want to say that in the fullness of time, our North Star is to deliver a live set of diagnostic features directly on the Azure portal, where you will be notified and can find issues on the spot. Okay. But that's going to take some time. So before we realize our long-term ambition, our immediate objective is to provide you with two things. First is being able to set the verbosity of log levels. As we all know that when log levels are set incorrectly, it can also play a heavy toll on your application performance. And second is, give you the tooling to capture and offload dump files directly from the Azure portal, such that you can then take the dump file and open it up in an offline analytic tool. In this case, it's a Java mission control to zoning and identify where the issues are. Okay, so that is all the slides that I have. And next up, I have a demo. Before I do that, let me check on how you guys are doing. Are there any questions? Okay, I don't see. All right, let me proceed to the demo. Okay, so what I like to do with all my demos is I like to give the audience a sneak preview on what the end result is going to look like before I get started, so you know what to expect. So in this case, we're using the popular pet clinic project from the community, and all we're doing is we're changing the display page size of the owner's page to a number that we're gonna configure. So this is what it's gonna look like. The end result is almost trivial, and to build this experience, we're gonna carry it out in 4 steps. The first step is we're going to create an Azure Container App environment. This is the environment that is going to house the other components that we're going to create. Okay. Second step is we're going to create the managed config service in Azure. And this config service is going to then connect to a GitHub repository where I have defined the page size. The third step is to create the actual pet clinic app on Azure Container Apps. And finally, we have one last step to bind the pet clinic app with the config service. Okay, so those are the 4 steps. Let us get started on the actual demo. Now, I have done the demo many times before the session, obviously, and I've got everything down to a script, so nothing should really go wrong. First thing we're going to do is setting some variables in my environment to say the location of the resource that I'm going to create, the name of the Java component, the URL of my GitHub repository. Once I've got that out of the way, I'm going to have to create a resource group. Okay, so AZ group create. As this is a boring step, but it has to be done and should take only a few seconds. Okay, so now my resource group has been created. We're now going to proceed with the first step of the demo, which is to create the Azure Container App environment using the AZ Container App environment create command. Okay, so this command is actually going to take a few minutes, as it needs to. There are many steps behind the scenes. It's as the screen says, it's now creating a log analytics workspace. So while this is running, I figured we can better utilize our time by looking at the code itself. Okay, so the code, I'm going to walk through the code changes, which is very simple. We go to the pet owner class. The only thing that I've done here is I have introduced this new line of change, which tells the controller to pull the page size from Spring properties. And if it's not able to find page size from properties, then use the default page size of 1. Okay, and the page size is used later on in the code to do the actual screen page size rendering. Okay. So that's a change. I have also added a refresh scope controller because during the demo later on, we're going to be changing the value of the page size, and we want to be able to refresh the page dynamically. And there is another class that I've created to carry out the refresh. We're not going to go through this code as it's outside of the scope of today's talk, but what I've done is here I've instructed the controller to pull on my GitHub repository every 5 seconds. Okay. And finally, in my pom.xml, I've added a dependency for Spring Cloud Starter config. This is part of the Spring Cloud project. And so there you have it. That's all the code changes I've done to the Pet Clinic open source project. Okay, let's come back to the demo here. The container app environment has now been created, okay, which is good. Now the second step that I'm going to do is I'm going to create the managed config service for Spring with this command. Okay, so AZ container app environment java.component create. Because the managed Java component lives inside the Azure Container App environment, this is why we're using the app environment create command. Okay. So over here, we're telling Azure Container App environment where to create it, what is the name of the pet clinic, what the name of it is, how we're naming the config service environment. But most importantly, this -- configuration is the flag that tells the config service where to pull my configurations. So this step is complete, and we can see that my personal GitHub repository has been set in the properties. So the config service knows go to this GitHub repository to pull the value of page size. Okay, so that is the second step. The third step is now to create the actual Spring Pet Clinic app. And we're going to use this command, AZ container app create -- name to specify the name of my app. And I want to point out, well, a couple of things I want to point out in this command. First of all, -- artifact is the flag that tells Azure Container App to use the ACH Cloud build process. Go to my target folder, grab the star.jar file, and containerize it, deploy it to Azure Container Apps. I only have one jar file in the folder, so it's safe to do star.jar, but if you have multiple, you need to spell that out. Okay. And the other thing that I've done here is -- min and max replicas. This is important because we all know Azure Spring, Azure Container Apps is a serverless platform, so it will scale to 0 when you do not have any activities. This is helpful as it will help you to save your cost when there's no activity. The Azure billing will switch from active to idle charge, which only bills you at a fractional cost of active CPU and memory usages. But just be aware, if you do not set the main replica to 1, the default behavior is that it will scale to 0. And when that happens, your HTTP request time is going to take a hit during the first request. Right. Okay, so that's the main and max replicas. And after that, we're also telling Azure Container Apps to open up an external ingress port on port 8080, so we can visit the Pet Clinic app from a remote endpoint. Okay, all right. So now what as you can see, the controller is now building the application. Behind the scenes, it's using the Paketo build packs, and this process usually takes a while because as there are different life cycles in the build process, it needs to go through. So okay, so now we see that the uploading process is done, and now it's doing the analyze, detect, restore, extend. Those are export. Those are all different life cycles of the build pack process. And once it goes through these process, it will finish the building process. Okay, there we go. The build is completed, and we can see the build logs from my local file directory. This is helpful in case if there are any build errors, and build errors can occur for the same reason. Build errors will occur locally, right? So dependency errors, for example. But this is where you can go to that file and pinpoint any build errors. Okay. All right. My container app has been created, and you can visit the app at this HTTP endpoint. So I'm going to make a copy of that. Okay. And before I visit that page, remember we have that one extra step, which is we have to bind the managed Spring Cloud config service with my app using this command. Okay, this should take only a few seconds. So -- bind a name of the Java component with the app that I just created. I think I lost this URL. Yeah. So let me copy this one more time. Okay. All right. So while this is on, okay, so that's just completed. My app is now bound, but it's actually not done because after the binding, it needs to refresh the app. But so if I go to my Azure portal now and paste the URL from the command line and go to pet owners, if I do find owners, it shows 1. Remember, because 1 is the default value that we have set in the code. And what's going on here is now because I just bound the app, it needs a few more seconds to have the new settings kick in. So I'm going to go to the vets tab and come back to refresh the page. And hopefully this time I should see, 3. Okay. It's now picking up the configuration from my GitHub repository. So now let's do one more test. I'm going to change this number from 3 to, let's say, 4. Commit the change. Okay, so now if I come back to owners, find owners, I should see 4, and that's indeed what we see on the screen. So there you have it. That is the demo. Okay. Second. Okay. All right. So now we have come to the probably the most important page during my presentation, which is we want you to get started on Azure Container Apps and explore Java yourself. You can begin your journey by deploying a Java artifact file to Azure Container Apps from our quick starts, following this AKA short link, and the link is aka.ms/ACAJD1. Again, aka.ms/ACAJD1. Okay. And lastly, your feedback is incredibly powerful to the product team. We constantly look for your guidance to make sure we steer our product to the right direction. So you can help us out by filling out the survey, scan this barcode. It should be a 3-minute survey, and tell us what you think. And when you do that, you will also automatically enter to win one of the 5 $100 sweepstake prizes. Okay.
Can you make it 4 and you give me one of them, please? Like, you know, we're friends here. $100 in South African rand is I can feed a family for a year though. I didn't know that you were giving away prizes though. That's even better than the 5,000 points we're giving away to the attendees.
It's a last minute thing, but I'm sure we can work something out between you and I, Rory.
Just remember, we go all the way back, Sean, all the way back. Hey?
We do. That we do.
Container apps and everything. So yeah, an incredible talk. I love container apps. Container apps for me are a way for me to play also. It's production grade, but you can also play if you want to just spin up a container. And also I use cloud native build packs that Josh Long covered a little bit there, and you can just go and it can create it for you and patch it for you though. Okay, so I want to thank you, Sean. Incredible session. We've got Yoshio, who's actually going to be speaking on something a little bit similar though, which is a generative AI. But the nice thing is that I've got quite a few applications running generative AI using container apps, because it's a great way. You've got Azure OpenAI, and you can just connect Azure OpenAI with container apps. I want to thank you, Sean. Thanks, and I look forward to that sweepstake voucher that you're going to
Thank you, Rory. Thank you all. Bye-bye.
I work with Yoshio every day. So Yoshio-san, thank you so much for coming on today. Please don't be too awesome, because I've got a session a little bit later on semantic kernel. So just be terrible at what you do, please, because you are a colleague of mine, and I want to not be too competitive around that. But you've got an incredible session coming up, generative AI for Java service enhancements, though. So without further ado, I'm going to hand it over to you.
So, can I start? Okay. So hello. So now I would like to start this session. So please take care of me. Before I begin, so let's briefly introduce myself. My name is Yoshio Terada, and I'm cloud developer advocate within the Microsoft Developer Relation team. And I'm also recognized as a Java champion. At first, I'd like to share the AI today. AI is not limited to the OpenAI's ChatGPT. As you can see, so it can be applied across various fields. So specifically, so AI can set a supplement to the human's eyes and ears and mouth. So for eyes, it's capable of the recognized text and image and video. And for ears, it understanding the human voice and interpreting the spoken language. And also for mouth, so it can convert the text to speech and the speech to text. So moreover, so AI can assist the individual with a physical disability. For example, helping the patient who have lost their voice due to the tongue cancer to communicate it using the AI. Beyond that, so AI can also perform the sentimental analysis, and it can capable of the text summarization and the categorization, then creating the image and the video, and answer the question and generate a new idea. And also it supports the programming task. So today I'd like to show you some of the specific example of how AI can utilize in this various way. So at first, I would like to share the non-open AI related AI services with you. So at first, so let me introduce you to a service called Document Intelligence. So this service was previously known as a form recognizer in the past. It's designed to read the static image or the PDF file, and it extract the text data contained with them. While it has been possible to extract the text data from image using the OCR technology for some time. However, as you can see, so in this example, when the service reads the data such as a business card and a receipt, it does much more just retrieve the text data. So it can also classify the content into the category, like the first name and the last name and the merchant name, providing the results that are organized by each item. By utilizing such an AI tool, you can simplify the process of the categorizing the image data and store it. So such a company name and the address, making it easier to manage and process this information. And if you want to integrate this feature into your application using Java, so we provide the Java SDK, and there's a lot of sample code available. So please feel free to take a look. So additionally, it is possible to generate the image based on the text description or the instruction. It is known as a prompt. By using the Bing image creator, so you can use the DALL-E 3 model. It is the latest and the most advanced text-to-image conversation model from OpenAI, which was just announced last September. And I enjoying the skiing as a hobby, so I created the prompt as a father and son skiing gracefully on the powdery snow of the Whistler to creating an image. Actually, I would like to go to the Whistler. And what you are seeing now is an example of the result that was generated. Additionally, so Microsoft provides the speech-to-text services, which includes the real-time voice translation feature. We have created the demo for this, so please take a look at it. 次に、スピーチトランスレーションのデモを行いたいと思います。このスピーチトランスレーションは、私が今日本語で話をしている内容をご覧いただいているように、リアルタイムで英語に翻訳をし、その結果を出力してくれるサービスになっています。また、このスピークアウトトランスレーションという機能を有効にすると、テキストの代わりにジェニーという女性の声で結果を返してくれるようになります。So like this, so real-time translation is available, and also so text. Sorry. and also, so text to speech is also available. So this is so Java source code, and this is some string, and if I executed this program, then so it will speak this message. So please hear.
This AI feature has the ability to convert text into speech, essentially allowing it to talk. It supports many languages, not just English. If you integrate it with ChatGPT, it's possible to have the text that ChatGPT generates be read to you.
So like this, so if you familiar with so Java, then so it is possible to create this kind of the program. So far, so I have introduced the future other than the OpenAI's AI's model. So there are indeed more convenient services available that due to the time constraint, I will conclude this part here. And now I would like to talk about new thing related to OpenAI. And before we get into the OpenAI, I want to say that so many AI models related to the OpenAI are now available in Azure. So like this, and the horizontal axis represents the type of the AI model, and the vertical axis indicates the Azure locations. As you can see, the location in the Sweden, so this blue line has the most AI model available in the world. However, so you might be asking which model to choose and how they are different from each other. To make an informed choice, I will briefly introduce what can be done with each model. The table here is a simple summary of the previous page. It shows the OpenAI model that are commonly used by many people at present. At first, so also not listed in the above table, I would like to introduce the text completion AI model. Models such as the Babbage and the DaVinci can complete the specific task according to the given instruction. These models are not conversational. It means that they don't remember the history of the previous interaction and the generated text based on a single set of the instruction. On the other hand, the ChatGPT is a conversational model that remembers the history of the past interaction and create a message in the conversational format. Next, so I'd like to introduce the concept of the embedding model. Currently, we use things like the ChatGPT to ask questions in the same way we talk every day. So it is called the natural language. So, however, so it is important to remember where this AI model is running. So as you know, so these models are trained by using the GPU, and actually it is running on the high performance PC. So while humans find natural language easy to understand, but computer find it difficult to deal with the natural language directly. On the other hand, computers are really good to dealing with the math or the number. So therefore, so by converting the natural language into the numerical representation, it makes it easier for computer to understand. For example, so search for similar sentence or use content. So this is when the embedding model became important. So by the way, so until now, we have been using the embedding model known as a text embedding adder. So this is a second generation model. And but so recently, a new third generation embedding model has been released. And using this new model allows us to achieve higher quality result at a low cost than the before, so second generation model. So I think that this third generation model will get more attention from now on. So please check that third generation model. And now, so it is available on the East US and East US2 and the Canada East. Only 3 locations it is available. And DALI 3 is also available, not only the Bing image creator, but we can use it on the Azure OpenAI services. And so if I put the same prompt on the Azure OpenAI services, then so this kind of result I got. And also, so if you are interested in to use the DALI 3 model in your Java project, I'm pleased to inform you that there is a Java SDK available for this purpose. This can particularly useful if you need to make a lot of image or want to make the image making process automatic. Using SDK to implement your code can be significantly convenient. And if you use the Whisper model, so you can transcribe the voice sound file into text and even translate them into another language. For example, so let me share an actual use case which I implemented before. So I extracted only the audio data from the video file, then transcribed the audio file into the text, and next I summarized the transcribed text using the ChatGPT. By reading the summary, it became possible to quickly understand the content of the video without having to watch all of it. And as you know, so I'm Japanese guys, and I went further to automatic to translate it of the summarized English document into Japanese, which was incredibly so convenient for me. And I believe so there are various needs around the world. So this is not just for the AI model. When you mix the different model together, so like Whisper and the ChatGPT and other model, so you can create something really special services. So I highly recommend you to give it a try. So lastly, I'd like to introduce a feature that has been recently added, which is quite the opposite of what I discussed the previous page. So actually, the ability to create the audio file from text. So unfortunately now there is no Java SDK available for this feature. So in this example, so I invoke it with the less code. In the model, we can convert up to 4096 characters of text into speech. And currently, it allows for output in the 6 different voices. So like Allo, Echo, Fabo, Onyx, and Nova, and Shima. And you also have the ability to change the audio format. So instead of the MP3 Opus AC FLAC format is available. Additionally, it seems possible to alter the speaking speed as well. So the default speed is 1.0 and the minimum is 0.25 and the maximum is 4.0. So you can change the number in this JSON file. And at this point, so I personally feel that cognitive services, text-to-speech to services is more useful compared to this. Actually, so in the cognitive services, so similar look like the same services is there, and compare with that, so I feel that cognitive services one is more useful. And if you are interested in the functionality, I suggest looking into the cognitive services text-to-speech, and Azure, so text-to-speech avatar services is there, and it is very, very fun. So please try it. Until now, so I have introduced the various AI capabilities from the cognitive services to the Azure OpenAI. So since now, I would like to share the SDK and the library that can use to integrate the AI functionality into your enterprise application. At first, if you are looking to the experiment with the individual model on the small system, so you can utilize the OpenAI library provided within the Azure SDK. And we have prepared the sample code for implement these AI model, so it may be easy for beginner to start, and I believe you will quickly get how to use it. Next, I would like to introduce the semantic kernel for Java, another library implemented by the Microsoft. And this library is particularly effective when more complex tasks are required, or when integration with other system is necessary beyond what the previously mentioned the SDK offers. When adopting the AI incorporating system, there may be an issue that can't be resolved with a single call to an AI model. In such case, using the semantic kernel can help implement the complex process with short code. It is not that these tasks can't be achieved using the previous SDK, but the amount of the code is needed to implement yourself. So to avoid reinventing the wheel, so we have pre-implemented the functionality that are deemed necessary, so you can focus more implementing the business logic. So for more detail, Rory-san will provide a comprehensive explanation in the EMEA time zone later. So please looking forward to the Rory-san's session. And so next, LangChain 4J is the open source framework currently under the development and the implementation, designed to handle more complex process. Being an open source project, employee from Microsoft, actually my manager have also participated in the project and contributing towards the integration effort with Azure OpenAI and OpenAI Search. As a result, LangChain 4J has started to support the use of the Azure OpenAI. So for more detail, Rise-san will provide the comprehensive explanation in the EMEA time zone later. So please looking forward to his session. And finally, Spring AI is also a library that works really well with the Spring framework. So in fact, During the keynote, Mark-san from the Microsoft demonstrated the application of the HMA fitness application, where the product inquiries were made to the AI directly from the browser. And in his demonstration, it showed there used the microservice made with Spring AI and includes the technology like the ChatGPT and text embedding other. So developing using Spring can also use the Spring AI library besides the other library and the framework mentioned before. So for more details, please refer to the session by Mark-san, which has already finished in the American time zone. Now, we proceed to develop the AI application using the SDK or library. So by the way, how about security? So when using the conversational chat GPT, how should we handle unexpected input from users? So for example, if like a sexual expression on the or violent expression on the or crime-related text are inputted from the user. And please imagine considering that if the children might access to the same services or same system, maybe many parents would want to prevent this. Furthermore, consider if it were possible to completely rewrite the behavior of the AI in the system definition, I imagine you would want to prevent such a occasion as well. So to ensure the safe use of the AI, Microsoft offer the feature that can reduce these concerns. So actually, this is fair. The feature called the content filter is used. With this tool, you can configure the acceptable range for the content by category. So for example, violence and the hate and the sexual and self-harm. So individual categories, you can configure. So from the in this time, all of the category was configured as a medium. However, if you'd like to configure more higher, then you can configure some of the category is you can configure the high. And also, in these places, jailbreak option was added, and if some like a cracker access to the AI services, and if the cracker overrides the existing system definition, then look like that it was called the jailbreaking. And to avoid the jailbreaking and to protect the system definition, this kind of if you configure this kind of configuration, automatically detect the jailbreak attack. Implementing the restriction on the permission language for each developer can be quite challenge. Exactly, like all of the word for the violence or hate and the sexual and the self-harm word, you need to check is a little bit difficult. However, by using this kind of tool, automatically detect this kind of the word and so preventing the unexpected behavior. So so like like using this kind of tool service, so you can make this process simpler and safer. So implement the restriction for each development. So yeah, I strongly recommend you to make use of this kind of tool. And finally, so when you're looking to use the AI in your business environment, it makes sense to want to use the information the company already has. However, right now, so AI model can only work with the data they were trained on. So then they don't use the information in the company file like a Word file or the PDF file or the Excel file or the PowerPoint file because it is not trained. Moreover, so even the latest preview version of the ChatGPT-4, ChatGPT-4 January 25th version, even so latest version, it is trained on the last year's December. So what can you do if you need to use the information the AI model has not run from? What it is pushed to what? So it is possible to fine-tune the AI specific data, preparing the large data set and set up the dedicated machines can be considerable effort. To meet these needs easily, Microsoft offer a simple way to use your own data. So this is made possible by feature known as bring your own data. With this feature, you can use the data kept in the Azure AI Search or Blob, or even recently from Elasticsearch is added. So you can ask the AI question by using this kind of data. Furthermore, the process to configure the system has been made very easy. So please take a look at the setup procedure. At first, I selected the Azure AI Search and I selected the existing Azure AI Search index. And after that, I enabled the vector search. And after that, I selected the property. And search type, so I can select the hybrid and the semantic search, and it is all of things is done, and I can ask exactly how to install the Microsoft Build OpenJ. I ask because I already inserted the Azure AI Search about the Microsoft document. So by using the Azure AI Search, it was get the result from the Azure AI Search, and so please refer to the one reference, and so if I click to the one reference, I refer to the document to the original file. So exactly, so I will push this link. Then, so this kind of file was referred, and this is the original data. So look like this. It is very, very easy to configure the outside of the data. So please try to create this kind of environment. And I
Perfect
finished.
timing.
Yeah. So thank you. I finished
Yes,
all
sir.
of the. Yeah.
Yep. I asked you not to do good. You did brilliantly. And now I've got my talk a little bit later today on, and thank you for mentioning semantic kernel. There's so much. It's like being a kid again. There's so many tools, and you've covered so many of them in your session today. Yeah, there's so much, and we covered how to use Spring Boot with it, how to use virtual threads, how to use generative AI. We just covered container apps. We used CraC there, and now you covered also the sessions there and how they can get started with it. I want to thank you very much from that. We don't really have questions. We've got a lot of praise. A lot of people in the comments said that you did incredible on the session there. I want to say thank you, and I want to bring in Cesar, who's our next speaker, who's going to be speaking on another real hot topic, which is Scalar replacement. Now, you really want to stay on this session, because if you are a Java developer, you need to know about the underlying JVM. So, Cesar, really, really great talk, though, and you're going to bring the nerd to it, though, because we need a JVM talk. We had so many, we had Spring virtual threads, AI, and everything. We need a hardcore JVM talk, though.
Yeah, let's see some assembly now.
COBOL. Okay, I'm going to hand it over to you, Cesar. Cheers.
Thank you. So hello, everyone. Good morning, afternoon, good evening, wherever you are. Thank you for joining in. My name is Cesar Soares. I am a senior compiler engineer at Microsoft on the Java engineering group. And today I'm going to present to you the work that we did to improve Hotspot scalar replacement. So this is our agenda for today. Not a lot of topics, just some fun ones. First, I'm going to present what is scalar replacement and why is that something that you should care about? Why is it interesting? And then I am going to, that's about Hotspot. What is Hotspot? And so on. And then I am going to present what we did to improve Hotspot scalar replacement. And then next, some performance numbers. And then to conclude, I'll show some remarks about the work. So I guess you are all familiar with this diagram, but I decided to include it just to be sure that everybody's on the same page. So to start executing your Java program, first thing is to write the Java program. Then you use a static compiler, which is JavaC. And JavaC is going to produce a class file with bytecodes. But to run the program, you need another tool. You need a JVM, right? And the JVM is a very large piece of software. It has several components. It has several garbage collectors. It has several actually bytecode parsers and interpreter and a few just-in-time compilers. And the talk today is about an optimization in the C2 just-in-time compiler. So what is scalar replacement, right? So as I just mentioned, scalar replacement is a compiler optimization. And the goal of this optimization is to remove object allocations. And it does not just remove any object allocation. The allocation needs to fit certain criteria. And the goal of doing that is to reduce the amount of memory that your program uses. And so your program is going to spend less time. The threads of your program are going to spend less time executing the garbage collector. And I am going to show you some examples later, but the way that scalar replacement works is by decomposing an object into its parts, like the fields and the methods. And instead of using the object to encapsulate all that, it's going to pick up the pieces of the object and move them to a different place. I am going to show you how this works in more detail. But again, why is it something important? Why is it interesting? So we all see a lot of people talking about garbage collector, how to better tune a garbage collector, which command line flags to use to make the JVM runs faster, use less memory, and so forth. So scalar replacement, it's a kind of different approach, but to the same problem. We want to make your program use the memory in a more efficient way. So scalar replacement is going to find objects that it decides decides that the program doesn't really need to allocate that object. We can execute the code and make it do the same thing without allocating this object. So it's going to put much less pressure on the garbage collector. But there are other benefits. By removing the allocations, the code of the method becomes simpler. Like when you allocate an object, behind the scenes, there is a lot of stuff happening to initialize the memory that the object takes, and to dereference pointers, a lot of stuff. So by removing the object from the scene, the code of your method becomes smaller, becomes simpler. And that on itself is something that already boosts performance a little, has the potential to boost performance a little. And the other benefit is that by making the code more simpler, other compiler optimizations can kick in and improve even more the code. So it's good all around. So let's take a look now at an example of scalar replacement. I am going to use this message class throughout the slides. It's a very simple class. You just need to pay attention really to the field here, to the content field, type string and public, and the checksum method, which basically just iterate on the chars of the string and accumulates the integer value of the chars and returns that accumulation as the checksum of the message. It's very simple. So we are going to use this composite checksum method as the example of a method being compiled by C2, and that's going to be, and that scalar replacement is going to optimize specifically the message that we are creating inside the loop of this method. So as you can see, it's not a very complicated piece of code. It's not, let's say, great engineering, but this is the kind of code that the compiler has to deal after some optimizations, because the compiler starts with a method the way that you write it, but then after some transformations, the shape of the code, it changes a lot. So at some point, the compiler may see something as simple as this, or something that you really didn't expect to have written, to be honest. And scalar replacement, it works on top of other two compiler optimizations. One of them is method inlining. And what method inlining does is it copies the code of a method. So the body of the method is going to be copied and replace it and use it to replace the call of that method. So in our case here, the portions highlighted in yellow are going to receive a copy of the message constructor, and then also of the checksum method. So let's see how that's going to look. So this would be the method during the process of scalar replacement, and during the process, the kind of sub-process of method inlining. On the first line inside the loop, we see that the content field from the message class now is a local variable inside the loop. So basically, the compiler translated that constructor code like to a piece of code that and put it inside the loop. Basically that, and the field of the class now became a local variable in the loop. A similar thing happened to the checksum method. The compiler copied the code from that method and put it in the place of the call to the method. And of course, the compiler just does not just copy. It adjusts the code so that it keeps working, right? So this is a very simple example. So actually, method inlining did most of the job here. But if we had a more complex case, now would be the part where scalar replacement would go and say, oh, this was a field. Now it's a local variable. So I just need to use a local variable instead of a field. That's what scalar replacement does, right? So it's a combination of method inlining and scalar replacement. There is another optimization actually called an analysis called escape analysis, but I'm not going to go into much more details because it's not a compiler talk. So after a few more rounds of optimizations, this is going to be what you're probably going to get from the compiler. Now we don't have allocation inside the loop anymore, and so less objects being allocated, less pressure on the garbage collector. So now I am going to show you what we did exactly, how we improved it, what we improved in C2. So we started investigating how can we contribute to OpenJDK, what would be interesting, and so forth. And we started doing some experiments with escape analysis, scalar replacement, all this sort of geek stuff in Hotspot. And we found that there are a few cases where the compiler just says, you know, I am not going to optimize this because of that. And one of these cases was what we call an allocation merge constraint, which is basically when you have a reference variable, let's say in this case, the m variable here inside the loop, it's a reference variable. And this variable can point to different objects during the execution of the method, right? So here we have this conditional checking that the message that we obtained from the list is null or not. And depending on the outcome of that, the m variable is going to point to different objects. So it's not always the same point in the code that's going to allocate the object pointed by m. So that was one of the situations that C2 was saying, you know, I don't know how to optimize this, so I'm just going to give up. I am not going to do scalar replacement in this case. There is a link at the bottom of the slides. You can find the report about all this and other situations where C2 would say, I am not going to scalar replace or optimize this piece of code. So this we considered an interesting topic to work on. We talked with the people from the OpenJDK email list, and they agreed. So we started working on it. So just to simplify the discussion for a little bit more, because now we know what is the problem, let's just focus on a smaller case, right? We are going to assume that we only need to scalar replace method object access that have field loads. So in this method here, it's kind of the same shape of code that we had before. There is a if-else or a conditional, and we create different objects based on the result of the condition. And then after that, we just use the reference to load a field from the object. So kind of same code shape, and we are only interested in field loads to make things simpler. So how does C2 see all this? How does C2 represent this method in memory, and why is it difficult or complicated to scalar replace this kind of code? So just to give a very, very quick idea of how C2 represent this method in memory, I'm going to show this figure that kind of illustrates how C2 represents the method. So in this picture, you can think that each of the rectangles or little squares there is an assembly instruction on the compiled version of the method. Just think about it like that. And the edges or the lines connecting the nodes, they are data dependencies. So it basically means that one node or one instruction produces something that's going to be used by the next node. The first two nodes at the top of the figure, they are to allocate memory for each of the objects that we saw earlier in the code. Note that these represent what the compiler sees. So it needs to consider all possibilities that, all paths that the execution of the method can take. So after the memory is allocated for each object, we need just to get a pointer to it, and then we cast the pointer to the type of the object. And then after that, there is this thing called a fee node. And here is where the allocation merge happens. This fee node is what the compiler, in this case C2, uses to represent the fact that it does not know which of these two objects are going to be really used during execution, right? So since it does not know that, because the decision may be based on a fact or on information that is only available at runtime. So the compiler just says, I'm going to create this node here. It's going to represent this fact that only one of these paths are going to execute, and I'm going to assume that. So after we, in the representation, after we come to this point and say, okay, here there is a link or a pointer to an object. We are going to load the value from that object, and we are going to return it. That's what the code that we saw before was doing. That's it. So why is it difficult to optimize in this case? The problem is that for scalar replacement, the compiler needs to know exactly from where each value of the fields of the objects are coming from. And since you have multiple possibilities, the compiler says, okay, this is something very complex to do right now. So, maybe it's better if I don't do it, right? So that was the reason. It was just a constraint in C2. It's not something that was not possible to do. It's just something that, okay, I'm not going to do it. So how did we solve the problem? We tried different approaches, and turns out that the simplest one was actually the one that performed better the benchmarks, and was actually the simplest one to also implement, not to just conceptualize it, but also to implement it. And the idea is, again, very simple. Instead of using these phi nodes to represent which object I should load value from, I'm going to use these phi nodes to instead represent the loaded value from the fields of each object that I need to return. So basically, what I'm saying is, instead of deciding which object I am going to load the value from, I'm going to load value from both objects inside the branches of the conditionals. And then I'm going to use the outcome of the condition, of the conditional, to decide which of the loaded values I'm going to use. So if I would write this in Java, this would be what we did. Instead of deciding which object we are going to assign to the local variable, we actually create the object and load the value from the field, and also do the same thing for on the other side of the branch. And then we use the decision just to see which of the two values we are going to use. That was the idea, and it took a lot of work to implement that, but at the end it worked, and I am going to show some benchmarks. But the idea is very simple, but it took a lot of work to do. So here I have a list of the things that were challenging to do. There are other things, but I have limited time here. I showed some very small graphs, but in reality, these graphs can have thousands of nodes. I have seen graphs with 15,000 nodes, so they become very, very big. So debugging the implementation is something really hard. Devising the algorithm to traverse this graph and find the right node to use for some given reason, it's difficult, because there are so many situations, so many use cases that you need to think about. I showed in the examples just loading a field, a single field from the object, but in practice we can load several fields, right? And you can have a mix of loads and stores. The objects, they can be used for different reasons, not only loads and stores. They can be used for as a monitor, for instance. And it also depends how you create these objects. Another very large piece of work was how to handle the communication between compiled code and interpreted code, because sometimes the execution of the method needs to switch from compiled code to the interpreter, and the interpreter does not know about scalar replacement. So doing this communication required a lot of work. And because of that, we created actually a specific pull request just to handle that part. It's the pull request on the bottom, which is already merged upstream. You can go there and take a look. And we also have this other pull request, which is approved, but not yet merged. You can also go there and take a look. So let's see some numbers now. We are almost done. So these are synthetic JMH benchmarks. I put just a few here. There are others in the pull requests. You can take a look. These benchmarks were created just to functionally test the changes, and also to see how they perform on ideal situations. So this graph shows execution time, and the blue bars are for the optimization disabled, or for before our changes, and the orange or red bars are for the optimization enabled. And the lower the bar, the better. We see that we saw improvements in a lot of benchmarks, and as expected, since these benchmarks show the kind of the ideal case. And we also have benchmarks where we didn't see a lot of improvements, and that was by design, because we wanted to make sure that in cases where we could not improve the execution time of the program, we would at least not slow down the execution. So we tested that too. So now on more realistic benchmarks, this is a subset of the Renaissance benchmarks. They are larger benchmarks, and this is more the kind of program that you are going to see in a real world scenario. Again, execution time, blue bar is execution time before our changes, and orange bar after our changes. We see that in a few benchmarks there was no change, no noticeable change. So we don't slow down the program if we are not able to improve it. But in a few cases, we see some really good improvements. Like in naive base, we see around 10% improvement. Scala Doku, around 20% improvement. And we saw the same kind of improvement in other applications that we tried internally. And not only in the execution time, but also in improving latency, throughput, and reducing the allocation rate of the application. So try it. Let us know what kind of results do you get. It's as I said, it's upstreamed already. It's enabled by default in the JDK tip. So give it a try. So some conclusions is, well, we talked with the community and we found this interesting problem to work on. They agreed that, yeah, this will be a great contribution. This is something that we think should be fixed. And we worked for over a year on this, me and another colleague, myself and another colleague. And we came up with a solution. People from the mail list helped testing this. We tried in some first-party customers, saw some interesting numbers. And at the end, we saw, yeah, this is really good improvement. Let's, upstream this and keep working on it. So we are going to push more work.
This definitely isn't your grandfather's Microsoft, because here we are, we're contributing, we're pulling in community members, we're helping with optimization, and we've got the finger on the pulse of what our community and our customers want, though, which is not only programmatically to improve the costs of cloud. We saw all of the sessions that we've had today, but also in the back end to actually make sure that we have a heavy investment in the infrastructure, which is the JVM, though. Cesar, incredible talk. And you did get your nerd on, which was, I was chatting to one of your colleagues on the side there in assembly and COBOL. From the questions here, we just got praise. One mention, Brian did mention, he answered a question there, the C2 just-in-time compiler uses for this method, intermediate representation. So you have Brian Stanford on the back end there answering the questions there. So no more questions. We have the great colleague, and you owe him a beer in that, though. So I'll see you. I'll work with you. I haven't worked too much with you, but now I know who to ask when I come to with issues. Thanks, and have a great rest of the conference. I want to bring Sandra and Nikita in, and they're going to finish us off with an incredible session on load testing. Just a reminder to do that Cloud Skill Challenge and to take the survey. And I'm going to hand it over to Nikita and Sandra, who are going to wind down this stream for us. And then I'm going to bring them on for live Q&A questions. Over to you, girls.
Thank you, Rory. It's so great being here. Thank you so much for being a wonderful host for the whole day already. But last not but least, I'm here with Nikita, and we're going to show you how you can optimize your Java apps for high traffic scenarios. Nikita, why don't you introduce yourself very briefly?
Hi, everyone. I'm Nikita. I'm a senior product manager working on Azure load testing. It's great to be here.
Thank you. I'm Sandra Ahlgrimm. You can find, and you also can follow me on Twitter at @screamhilt. I'm one of the developer advocates working for Java at Microsoft. And load testing is so important because it will prevent you from like high impacts, like there had been bad things happening, right? And high load, it's not actually a bad thing for your app and for your business, because imagine there's Black Friday, you really want to have like high loads hitting your app, you want to have the best sales, you want to make the best use of it, but be prepared, because otherwise like damage can happen. So we have it here. There were some very severe performance issues in the past with United Airlines, or also the Tokyo Stock Exchange, Google, Amazon, you name it. And hopefully not your business was impacted. But just to be very safe, you should make use of load testing. Is that hard to use it, Nikita? Can you tell me more about it?
Oh no, it's very easy to use it. So let's talk about Azure load testing. So Azure load testing is a fully managed service which enables you to generate high scale loads, simulate the traffic that you need to test your services, and make sure it is resilient enough when you are expecting your peak traffic. So let's talk about a few things that Azure load testing enables you to do. First of all, it generates high scale load quickly and easily. So you don't have to worry about spinning up any infrastructure that is needed for you to generate the load. Everything is taken care by the service. You can just run existing Apache JMeter scripts. Apache JMeter is a Java-based open source framework that is widely used in the load testing community. You can just plug your scripts and run them at scale on the service. Not just that, you'll be given at the end of the test, you'll be given the test run details like the client side metrics that JMeter reports, as well as if your app is hosted on Azure, you can also see the server side metrics of how your application performed during the test. So it makes it very easy for you to correlate the load that was generated versus how was your application responding. You can catch bottlenecks that are there in your application and fix those to make sure that your application performs well. So if you are testing on a regular basis, it helps you catch your performance regressions early on. So it is recommended that you put your load testing in your CI/CD or DevOps workflows, and make sure that every time there's a major release happening, you first load test your application on a pre-production environment to make sure that the code that you are deploying in production is performant and is meeting your expectations for say response time or throughput or whatever SLAs or SLIs that you may have. Yeah, so Sandra, what do you say? How should we just show how this works?
Oh yes, I can't wait to see it, because as a Java dev, I have JMeter installed on my local machine, so I should have the scripts. So maybe we start from there, and then you can show me how I could use it with Azure load testing.
Sure. So yeah, we'll talk about a demo which is about the pet clinic app. So this is the Java Spring app. It is currently I've deployed this on an app service. It has a database as well. So this is a simple application which helps you find owners for pets, find vets, add a new pet. You can list your pet here. So it has a lot of functionality here in this app. So let's see if we can load test this. I have my JMeter GUI open here. So JMeter gives you this GUI where you can very easily just click and add any configuration elements. And once you are done running it here, you get a JMX file, which is an XML format of the JMeter script. So it's very simple. You can just add your elements in the UI. You can see everything, and you can just run the script here locally, and then you can run it at scale if you need. So let's look at what is there in the JMeter script. So this is a thread group, which basically defines what are the requests that are contained in my thread group. So each thread in JMeter will execute all of these requests sequentially. So I have defined 250 threads, which is like 250 concurrent users hitting my website at one point of time. And I've given ramp up duration and like I give 240 seconds, which is like 4 minutes of the test run. And I have added all my requests here. So these are my HTTP requests for my website. So I've added a request for the home page to find all owners. I'm testing that request. I'm testing find with last name, add new owner, and add new pet. So these are some of the requests that I want to test, which gives me the end-to-end visibility of how my application is responding. So what do you say? Should we run this on Azure load testing and see how it runs?
Yeah, I would love to see this. And I would also like to see if you have to set up VMs and if we might get blocked because of DDoS attacks, because it looks a bit like it.
Okay, let's look at that. So, yeah, as you said, it's very simple. You don't really need to like spin up any VMs, right? Everything is taken care by the service. This is an Azure load testing resource. So resource is like a hub where you store all your tests and you have all your test runs for the test. So as you can see, I can just upload a JMeter script and start creating my test here. So let's look at this. So this is a very simple this is a very simple flow where you can enter all the details that are needed. The first tab is just like basics tab that you can use to rename your test. Let's look at this where you actually now you can upload a JMeter script. So a JMeter script is all that you need to create and run a test. You don't need anything more than that, but all the other options that we give you enhance the functionality of the service. So let's upload a JMeter script here. I'm taking my petclinic.jmx file and I've uploaded it. And I can just run it now. But since I want to run it on more load, I want to provision more engines and not just run on one engine. I can go to the load tab and here I can say how many engines I want to run. So remember we defined 250 threads in the JMeter script. Now I can give, say, for example, 8 engines here. And when I give that 250 is multiplied by 8 and I get 2000 concurrent users. So we support up to 400 engines. So that is, for this test, I could like run 100,000 users very easily without me having to worry about spinning up the infrastructure. If your app is not publicly accessible, you can also test a private endpoint through VNet injection. So that's as simple as that. One very big advantage if your app is hosted on Azure is that you can monitor the server-side metrics during the test run. So for example, since my app is hosted in this same subscription, I can also go and search for the app here. So I'm searching for my resource group. As you can see here, I have a few, I have the app service plan, I have the database. So I want to monitor these when my test runs. So I can just go and hit review plus create now. And this will create a test for me and the test run is also kicked off. So in interest of time, I've already run the test and we can take a look at how that looks. So let's go ahead. I had created a test and I had run the test. So this is how a test run looks like. As you can see, you get all the end-to-end details of the test run and how it performed during the run with the load that you had simulated. So as you can see, I had around 2000 virtual users of load. And I do see that my response times were quite high. As you can see here, it was in minutes actually, which is not good. I expected it to be better.
So
I can
adding a
see
new
how
pet takes like more than a minute. Is that what it's saying? Is it on average?
Yeah, so this is the 90th percentile. Is you can always check for whichever aggregate you want to check, but I'm seeing the 90th percentile is quite high. So I'm not sure what's the issue, Sandra. Do you think we should check what's the issue with this app? What do you
Yeah,
say?
you say it's the app, right? Because I can also check like with the system and the load testing, everything is fine. Because Java apps are just perfect.
Yeah. I
Yeah, it
wonder
doesn't
what
look
is
like it,
causing.
right? Okay, so why don't we have a look at the code first? Because the load test is a nice way to measure what we did and if everything is running fine. It doesn't give us like right away steps to do to perform better. So first thing, like all cloud resources, we can check if everything is deployed in the same region. But I believe I saw it earlier when you clicked on which regions to show it was all in the same resource group, and it was in the same region. So why
Yes,
don't we have a look at the Java
everything
code?
was in ECS2. So sure,
Okay.
I can take you to the repo. So
Yeah,
this is
here's
my
the
repo
repository.
and this is the code that I have.
So why don't we have a look at the POM XML to check, for instance, which Java version is used? Because I see here like last commit is like 2 years old, 4 years old. I mean, it's the fork of the famous pet clinic application we kind of store from the Spring examples.
Okay.
So let's see when it was last updated. Oh, line 18. Oh no, that almost hurts. It's Java 8.
I see.
So whom of you is running Java 8 still in production? Oh, okay. Maybe we should have a look why you should update, like very briefly. We do have a slide for this.
Yeah.
Okay. So top reasons to update from Java 8 to 17. First of all, there is actually almost no long-time support any longer. So like for Oracle, they stopped it. We don't have it. Maybe if you have like a very special contract with your field engineers, but usually it's just not supported any longer. So please be safe and update. Then we have language level enhancement. So your develop team will just love you if you finally allow them to update because they want to make use of the newest JDK versions. So do I as a Java developer. Then we have increased security features. Don't miss them out. Please, please, please update. And then we also have extended APIs and libraries. So even though Java is just wonderful, almost perfect itself, we can now make use of extended libraries. So we can use, for instance, the toStream methods and various others like better JDBC connection, you name it. And there's probably also more, or very likely also more to come. So please update. And finally, they promise us performance improvements. So why don't we check this? So when I will share my screen now. And then I just did a new fork of the Spring project, Spring Pet Clinic. And I deployed this. Can you see my GitHub repository?
No, Sandra, not yet. It's coming up.
Okay.
Yes, I see it now.
Great. So as I said, it's a fork from the Spring project, Spring Pet Clinic. I just clicked fork. And then I opened that in my VS Code or whatever IDE you like. I used the Maven plugins to deploy it towards Azure Spring Apps. So I just did what you did before. So here's my Pet Clinic resource group, and here is my MySQL database as well. And here's my app service with the Spring Pet Clinic. I can also open that up very shortly. So here again, it's my dashboard with the East US pet clinic. So I deployed it twice, and I will show you why. So I found that with my load test. So I used the same load test. Just remember to give in the parameter your Spring app or your application, your web app, and then you can do that. So the first one I did gave me this one. So I had kind of a nice throughput. And then I only had 250 users at the time. And then Nikita said, wait, Sandra, you should run like 8 instances. And I was like, oh, wow, sure, you did that. I wasn't listening carefully. So you can still configure if you go here. And then you can also give it parameters. So, but main thing was the engine instances. I forgot to set it to 8. So I did that, and then I was able to run it with 8 instances. So I already had the better load here. Let's see, it's kind of funny. So let's see. And also the time, still a lot. So let's see. And then we discovered that I wasn't running on the same size of my app service. So if you deploy your applications on resources on Azure, you always have to select the plan. And of course, if I use like the cheapest machine, development machine, I don't get what I will get if I pay for production ready ones. And then I also missed to add the monitoring. And then I also wanted to test with the database. And when I tested with the database in place, it was like very slow, like still 35 seconds, or here more than 2 minutes. And I was like, oh, no way, we can't have that. I mean, we just managed to upload or to update from 8 to 17. And by the way, I did a new fork to also have all the new language features in place from Java. So, and here I also got errors, and I was like, where is that coming from? And then I checked, and they weren't all in the same resource group. So like here, this one is in West Europe. The database is in East US. So make sure you have everything in one place. So like here, this web app is also in East US. So everything in one place. I reran the tests. Oops. So here are my tests, and here are now my load tests in East US. And first thing, I ran it. And again, I forgot to set up the instances, but it already looked a lot better. And here's also the request per seconds in average. It's kind of all right. So milliseconds, that's what I want to see, because, you know, as a user, I want to see immediate responses, right? I don't want to wait forever. And here's even with my 8 instances. So now I have the same setup that Nikita has. Only difference is between Java 8 and 17. And you remember her numbers, right? So here's like my super fast response time. So that's like super great. I only have like seconds and not minutes. So it's kind of all right. I have my 2,000 users. I have 0 errors. So good job. So that's working
that
very
is
fine with
great.
my Java app here. Yeah?
Yeah, I think this is a significant improvement on the Java 8 version. I definitely need to upgrade my app.
Yeah, that would be so great. And you also add new owners, just very little seconds. And this time, if you have more look into our monitoring, you can also see that it's mainly the database that it's now like the weak point I have here. But that's another story. But for my Java app, and then I can also see here my CPU percentage, memory percentage, my consumption. And here you can also see how it's going down. And yeah, so that's pretty cool. And if I would run that longer, you would also see that it's getting more efficient. And that's what we get with the JVM, right? It needs some time to warm up, and then the results will even start to get a lot better.
Mm-hmm.
So that's pretty cool. Also here are the sampler statistics. So if I need to get that written down, find all owners, add new pet, add new owner. And obviously we left some space for improvements, because now we only check to find them, to add them. We could have also added them and also delete them. I feel that's missing, because what I get now, if I check my app, here it is. And I go and find owners. You see what we did here, right? So now I have like a lot of Serena Davis's edit. So please, if you run your load test, make sure you also delete the ones you don't want to have. And obviously, that's probably something you want to do on your quality environment, not really on production, unless you have like a time where your app is not running or not in productive use. Then you could do it as well. But make sure for your data persistency to do those correctly.
Absolutely.
Yeah, so let's see, how much time do we have? We're almost at the end of the time. So you can see again the test runs. Yeah, why don't we go back to the slides from here?
Yeah. So yeah, we saw why we should upgrade. Sandra showed us live how it made such a big difference. So please load test your app. Make sure it is running on the latest Java version. All the good things that you can do to improve your performance, you can do that. And you can validate that by running a test again and making sure that it's meeting your criteria.
Yeah, and thank you for providing me the load testing, because otherwise I wouldn't have been able to clarify that with my upper management, because some of them, they're kind of raised with Java 8, so they would love to stay with this forever. Can you go next slide, please?
Yeah.
So if you want to find out and try yourself, we have the repository here. It's also in the QR code, so you can have a look. You also can find mine and my GitHub at Sandra Ahlgrimm. And please don't miss out the product page, the documentation. They also have a blog for Azure load testing and also the feedback forum. How to set up this app with Maven. I will publish a video on our YouTube. It's Java on Azure or Microsoft for Java developers. You can find us there. So now we're here for questions. Please put them in the chat and we will answer all of them. Thank you so much for having us. Thank you, Nikita.
Thank you.
That was an excellent roundup to the sessions. And I love the fact that we support Java 17 and we recommend people to move to it. And Java 17 actually has, if I remember, the preview of Java virtual threads. So you can actually get started on with it. A lot of the features that we saw today, though. Sandra, Nikita, I'm just going to go quickly, just look at the questions here. I think there were a lot of Java 8 questions out there.
Upgrade
21. Yeah, 20. I don't know about 21. Hey, like that makes me a little bit worried though, because some of those features in Java 21 I don't even know about. It's just some people say Java's moving too slow, and then other people are saying Java's moving too fast though. But if you have good load tests, then you can actually upgrade, because you can regression test and make sure that your system works though. And that's one of the key takeaways that I had, Nikita. Maybe if we can get your input around that. What is your feel for, what is the main purpose that you would like to give the audience on why they should test their applications?
Yeah, so we've seen different scenarios in which customers are using the service, right? So one very important one is when you are, if your business is having like an event. For example, there could be a tax event and you're in that industry, and you are seeing that there might be a surge in the traffic. If you are in retail, you could have the Black Friday sale. So there could be these peak events for every industry where it's important to ensure that you have tested for those peak loads. But there's also a continuous development cycle that happens, and you have major releases throughout the year. So it's important that you put it in your DevOps workflow. Make sure that for every major release, you actually test it before you put it into the production environment. So you do a pre-prod testing.
That's very relevant, because there was a recent attack by Midnight Blizzard, and Sandra and I have been kind of rallying around testing our systems and our code around it. Though, Sandra, your takeaway for why load test and what is the security implications of load testing?
I'm not sure about the security implementations, but I would definitely recommend using it.
We want to be secure, so we want to test kind of.
I'm secure for loads. Yeah.
Yeah.
Not really for vulnerabilities. That's why you update your Java versions and everything else. But for load, it's just great to have it. Because as a developer, of course, I tried to do it all by myself. But then, first of all, I had to set up all the machines. And then my app was blocked for DDoS attacks, because that's kind of what it feels like for my application stack if I do heavy loads, like immediately, suddenly. So it's clearly the better thing. And I really love that I can have JMeter in place and then just use my scripts. Or I go with the portal and just click through it if I'm not familiar with JMeter. But as a Java dev, I know what I'm doing here. So it's just great.
It's perfect timing with Midnight Blizzard, just ravaging a lot of the corporates there. Nikita, Sandra, I want to give you an opportunity to say goodbye to the whole stream here. So if you have final words, what would you like to say to the audience? Nikita first.
Yeah, I think it was a great session. The entire stream today was really energetic. A lot of different content from different teams, different people. I think it was great. I really enjoyed the stream. I hope everyone has enjoyed too.
And Sandra, say goodbye to our audience.
Yeah, goodbye. But we will see each other very soon because I'm the host for the European stream. So you
and I'm going to be
miss
joining
me.
you. Yeah, so everyone, go get a break. We've got the European stream starting soon. I'm going to be speaking on Semantic Kernel, and Sandra's going to be hosting, so you know it's going to be good. Nikita, Sandra, thank you so much. Excellent session there. Thank you, audience. You've been so gracious. Remember to do the Cloud Skills Challenge and also to take the survey. We're going to put the survey up on now. So, and then I'm going to drop off there, and I want to thank all of you for being a participant of Microsoft's annual Java conference, and I look forward to seeing you next year. Thanks, everyone.